Hello, everyone. Good morning. Welcome to jCloud conference. We are really glad to have you all with us. So we are going to start off with the sessions in just like 15 minutes. So first we'll have Srinivasa Rouse session. But before that, I'll just quickly drive you through the agenda of today and how can you go through the learning resources and the other learning materials. So okay, so I'm sharing my screen. Hope you guys are able to see it. So guys, let me run you through the agenda for today. So we are going to start off with the first session by 1:15 a.m. IST. Our first speaker is going to be Srinivasa Rao from Visa. After the session, we are going to have Sandra from Microsoft from 11:50 a.m. IST. Then we are going to have Rory from Microsoft from 12:25 p.m. After Rory's session, we are going to split and we'll be heading for the lunch break. So our lunch break is going to be from 12:55 p.m. to 1:30 p.m. IST. After lunch break, we are going to come back and we are going to have game time. So guys, we have a game time for all of you. So I would request you to come back on time so that you don't miss out on the game time. So after the game time, we are going to start off with our afternoon sessions with Arvind from 1:45 p.m. It's going to start from 1:45 to 2:10 p.m. IST. After Arvind's session, we have Soumyadip from Hoichoi. So his session is going to be from 2:15 p.m. Afterwards, we are going to have Haimantika from 2:35 p.m. And at last, we are going to have Arpita Srivastav from Microsoft Student Learn Ambassador. Her session is going to be from 2:55 p.m. to 3:10 p.m. IST. So guys, after Arpita session, we are going to have the closing note and the winners announcement for our referral program, the referral contest we were running for jCloud Day and also for the quiz contest. So let me run through you the housekeeping rules. So guys, we are going to record all these sessions and the links to all these slides and recorded sessions or learning resources will be shared after the event via email and updated on the website. There will be a Q&A session after every talk and the speaker will try to answer about 3 to 5 questions. That depends upon the time they have. And also guys, we request you to post your questions in the comment box so that the speakers can go through it and answer most of them. So also guys, I would like to request you, so please do not post any irrelevant questions. We would appreciate if you could post questions related to the session or any technical questions. So this is the agenda, so you can go through it. We are going to start with the first session by 11:15 a.m. and after lunch break, we are going to start for the afternoon session, starting with game time. So guys, we have a code of conduct for the conference. So I would request you to abide by the code of conduct. So this event is dedicated to providing a friendly and welcoming experience to all attendees, regardless of gender, sexual orientation, disability, ethnicity, and religion. All participants are expected to display a positive community spirit, obviously because the event is totally driven by community and exercising consideration and respect to all that attend. Unacceptable behavior or harassment of event attendees in any form will not be tolerable. So guys, you can go through the whole code of conduct from this link. Is konfhub.com/code of conduct. So guys, regarding the quiz, so our quiz is going to start by 1:30 p.m. and it is going to start just after the lunch break. So request all of you to join for the quiz and don't be late so that you don't miss out the quiz time. So our top 3 winners will receive rupees 500 cash. So guys, we would love if you could share about the event and let us know how you're enjoying the event. You can make a post on Twitter by uh, using hashtag jCloudDay and tagging KonfHub on those posts. So this whole conference has not been like a successful without the community partners. So we have got really cool bunch of community partners for jCloud Day. So I'll just name all of them. So we have Bangalore Jug, we have Coderflex community, we have Delhi and NCR Java user group, we have Elastic user group, then we have Girls Grid Foundation, we have Java Meter Bangalore, we have Java user group Hyderabad, we have Kerala Java user group, then we have Mumbai Jug, then we have Script Foundation, and we have Women in Machine Learning and Data Science, Mysore. So guys, a lot of you will be asking for the learning resources which could help you get started with Java and cloud and also help you upskill. So here's the link for where you can find all the learning resources. So it's con.me/jcloud hyphen content Java. So guys, here you can find all the learning resources on Java for cloud developers. So I would request you to go through it. This will really help you. Sorry. Yeah. So guys, we also have Azure Dev Challenge. So it's really cool. You can even earn Azure Hero badge after submitting and participating in this challenge. So let me show you how it is. So this event is specifically, this challenge is specifically for jCloud Day. So what you have to do exactly is you have to go through any of the learning path and complete it. And you need to share your MS Learn profile and the achievement badge with hashtag jCloudDay on Twitter. So all you need to do is just complete the learning path, any of the learning path, share it on Twitter using hashtag jCloudDay and share your MS Learning profile. And subscribe to the Microsoft.source newsletter. So what is this Microsoft.source newsletter? So here you can find all the digest of upcoming technical events, conferences, trainings happening, and you can also find the relevant technical contents here. So guys, you can definitely go and subscribe to it to get the monthly digest of all the technical relevant contents. Regarding the Azure Dev Challenge, let me show you the learning paths we have. So guys, this is totally for jCloud Day conference. So you can go through it. So we have 4 different collections. So these are here. Anyway, we are going to share these links in the comment box so you can go through it. Guys, then we have, last but not the least, this event is being sponsored by Microsoft Azure. So we are really thankful to them. So without wasting any time, let's get started. So I would invite Srinivasa Rao from Visa. Hi, Srinivasa.
Hi Rohit. Yeah, thanks for the nice
Yeah, hi.
introduction
Good
and
morning.
good morning.
Yeah, how you doing?
Yeah, I'm doing great.
Awesome, awesome. So, uh, we are really glad to have you, Srinivasa, for jCloud Day conference, and we really appreciate you accepting and coming to the conference and sharing your knowledge. So, without wasting further time, so Srinivasa, I would request you to give a short intro about yourself, like what you're doing and why are you so much interested in contributing to communities and community events, and what is your session is going to be today.
Yeah, sure, Rohit. I'm working in software industry for the last close to more than 23 years, and I like pretty hands-on development work. Currently working on the large data sets processing and using machine learning, artificial intelligence, and big data computing technologies like Spark and distributed computing. And my passion is always to share the learnings, whatever I know a bit of, so that it helps the community and it helps the other people. And nowadays, it's a wealth of information there in the internet. Okay, so
Yeah,
people has to allocate some time so that right everything is possible in this time. Okay, hope everyone is safe during this pandemic situation, and really appreciate the people for taking time and allocating their valuable time to attend this conference, Rohit.
yeah, definitely we do. So, Sirivan, would you like to share your screen so that I can present it and you can start?
Yeah, sure.
Sure.
Is my screen is visible, Rohit?
Uh, not, not exactly. So, so in the bottom, you can find a button called Share Screen.
Yeah.
Yes, I can see that.
Okay. Is
Okay.
it loaded?
So, yeah. So here you go.
Okay. Um, Thank you, everyone. Good morning. As indicated earlier, um, so I will be talking for the next 30 minutes and sharing my experiences on continuous performance engineering. So most of the times in most of the organizations, they have a practice for continuous integration and continuous deployment, but very few organizations follow continuous performance engineering aspects as well from the beginning of the project together. So a bit of myself. So I started in some small startups. So then I moved to HP. So there I worked as a middleware architect and got an experience in benchmarking and performance tuning of large data sets. Then later I moved to BA WebLogic. So that's where I got a hands-on experience and then architecting the performance benchmarks and working with spec groups. Okay, and got a reasonable experience in the performance industry and benchmark standards. So then I started an interwoven as a development manager. So started building the production content management side and machine learning side. And before joining Visa, I spent 10 years in Cisco. So there I led few projects in customer experience, Cisco services, and innovation products using machine learning and artificial intelligence. And for the last 4 months, I'm working in Visa as a director, working on the data platforms. I'm proud to say that I'm one of the coach and mentor for an almost 100 engineers course from IIIT Madras and Upgrade, which is an advanced certification in machine learning and cloud. So I would like to bring up two issues. If you see that the relative cost of fixing defects found at different stages in software development lifecycle, this is a known thing as per the National Institute of Standards and Technologies, as per the NIST. If you are able to figure out, find a bug during requirements or during coding, it takes less cost, okay, less number of hours to fix the issue when compared to the same bug when it is found during post-production or during the production, okay. And then second issue is, this slide talks about the garbage collection, especially for the Java applications. Garbage collection takes a significant role. If your application is spending significant amount of time in garbage collection, so then it has a dependency, okay. So there is a large dependency on the throughput as well. There is a significant loss will be there in the throughput if the percentage of GCs increase. And then it's worst in case of multiprocessors. Take for example, if an application is spending 30% of the GC, and if you are getting a throughput of 1, then almost like the loss is 80% throughput loss on a multiprocessor system if the application is running on 30 CPUs, for example, okay. So this is what the benchmarks as per the Oracle Java Standard Edition 8 and 9 documentation. So in my view, every Java developer, every Java engineer, whether you are building the application on premises or in the cloud, should have a focus on the garbage collection as well. So how to address these two issues, okay? As I mentioned, so one of the approach is implementing continuous performance engineering. So what is continuous performance engineering? Similar to continuous integration and continuous deployment, you start using performance engineering from the beginning of the application during the development itself. So you select a tool, application performance profiler, which has less overhead, so that you can run your unit tests along with your CI/CD pipeline and integrate this profiler as well, so that you will get the profiling recordings for the same unit test whatever you are running, okay. You have to enable some of the profiler options, and then you will get the profiling data as well. So you can baseline the application performance and compare the performance results for each pull request, assume if you are using a GitHub. So as one of the best practice is, so whenever a GitHub pull request is raised, compare the baseline performance data along with the updated new code performance data, okay. And then some of the things you can make as a checklist saying that, hey, the new code doesn't increase the socket IO or file IO, and similarly there is not much increase on the percentage of GC, or the CPU, memory, disk, network, some of the system resources utilization is not increased from previous build to the new build. If there is a proper reason, so then worse. But assume like if there is no, if you are fixed there in the new bug, so new code, so then you can reject the pull request itself. So this is one of the best practice people can start following it. So this is the slide I've taken from Azure Web Apps, how you can use Java CI/CD using Jenkins. So IntelliJ or Eclipse, and you develop the code and submit the code into GitHub. So then it triggers a Jenkins workflow. It builds a container from Azure Container Services, and then it gets a pull request from the Azure Spring Cloud. the artifacts from Azure file systems and then builds it like MySQL. So far, so good. So then you can monitor that application using Azure Application Insights as well to figure out some of the performance overheads, some of the performance counters, and Azure Application Insights supports the JMX as well, Java Management Extensions. So that also you can make use of to intercept and then instrument some of the code. With this, I would like to focus some aspects on Java garbage collection basics. In Java heap, if you see the blue color boxes, so these are the occupied objects in the Java heap. Okay, so when a garbage collection triggers, it marks the unused and unreferenced objects, so that you can say that they're in orange color. All blue color objects are live objects. So once a Java garbage collection marks these entries, hey, they are ready for garbage collected, and then in the second phase, it will delete these objects. Okay, so assume like all the orange objects, all unreferenced objects are deleted. So then the heap memory looks right, the gaps in the, it will not be a contiguous. So that's why then it will do the compacting as well after the deletion. So this is a bit of garbage collection introduction. That is a mark and sweep garbage collection. The next is I would like to focus more on the thread local allocation buffers. As you know, hotspot heap structure, and the heap, it is divided into two spaces. One is the young generation, and the other one is the old generation. And the parent generation is for the JNI side. And the young generation is further divided into hidden space and two survivors. So whenever you create an object, that will be created in the hidden space. Then after the GCs, it survives from survivor 0 to survivor 1. Then it will move to the old generation. You can set the options for new generation size, and then what is the survivor ratio, or 1 or 2 or 3 or 5 or whatever, 1 to 10. You can specify that as well. So now what happens is, as a thread local allocation buffer, assume like your application has a lot of threads. Each thread has to create an object in the hidden space itself. Okay, in order to properly synchronize, JVM it creates a thread allocation buffers for each thread within the hidden space itself, so that that thread can create objects within the given TLAB itself. Okay, so it's pretty easy to synchronize within the JVM threads, and you can specify the TLAB size using the Java options, and then you can resize some of the TLAB options as well. But as I would cautious tell that don't play with this unless until you have a experience in that. Okay, don't try in the production, but you can try in the non-prod, and then later you can increase or decrease TLAB size. But most of the JVMs have adaptive TLAB size, so they will be able to adjust the TLAB size based on the number of threads, and then object sizes, etc., etc. So some more data on the TLABs. In the top side, if you see that the hidden space is created, and then when you start a new object, it has to create in the TLAB. But assume like the new object size is much larger than the available TLAB size. So in that case, what it has to do? So it has to create the new object outside the TLAB. Okay. So if whenever the TLAB size doesn't fit into the given, whenever the object size doesn't fit into the TLAB, so then it has to create in the hidden space outside the TLAB itself. So that is one scenario. The second scenario, so the application is creating too many objects. Okay, assume like one particular thread is creating too many objects. In that case, the TLAB size is full, almost full. And then the same thread, if it has to create a new object, than the available size, then it has to create the object in the hidden space, but outside the TLAB. So make sure that outside the TLAB, and as much as possible, all the much there is less impact. Play with that. The specify how much is the TLAB waste can be based on your application, but be cautious when you're playing with these TLAB sizes. Then there are garbage collectors available from JDK 1.2, 1.3 till 1.14 or 15. And these are all the traditional garbage collectors, the serial garbage collector. So this does the mark and sweep in a serial fashion. You can use the serial GC option. And this is mainly if a large number of JVMs needs to be run in one particular server. So you can make use of the serial JC. In the parallel JC, as the name suggests, it does the mark and sweep in parallel. So you can specify the parallel JC option, and you can specify the number of parallel JC threads as well. So if our system has 32 processors, so you can use parallel JC threads as 32. And by default, if you don't specify any JVM option, JVM will pick up one of these options based on the number of CPUs available in the system. And the next one is the concurrent mark and sweep, the CMS collector. So this is basically a low pass garbage collector. So this is used for low latency applications. Okay. And the next traditional garbage collectors. There are the new garbage collectors, JDK 12 onwards. One is the G garbage collector. So you can specify the option using -XX plus use GGC. So this garbage collector beauty is, on a single JVM heap, you can set up to 18 terabytes itself. Assume like the Java application which you are running requires terabytes of heap, and at the same time, much less impact on the garbage collection. You can go with G garbage collector. And the next one is Shenandoah. So this is also like G garbage collector for large heap sizes, and it can run in 3 modes. One is normal mode, another one is experimental mode, the third one is passive mode. So normal mode happens mark mode, and in this marking mode similar to G1 GC. In case of IU, that experimental mode, this is basically the concurrent GC. And the third one is for diagnostic, right? In the passive mode. If you are using some functional testings, you can make use of Shenandoah with passive mode, so that you will figure out and the stop the world garbage collection mode called C4. This is the commercial one, and this doesn't have any pause times. So that means during the garbage collection, it doesn't pause the application threads or JVM threads. So it's for very low latency applications, we can make use of Azure C4 as well. In fact, Azure supports the OpenJDK builds on Microsoft Azure, so people can make use of that as well. So as I mentioned, for the continuous performance engineering, we have to select a profiler. So the profiler should be less overhead. It should not cause more overhead. So one of my suggestion is to go with Java Flight Recorder. So Java Flight Recorder is a bit of history. So it started in BEA. that time it is used to call JRacket Runtime Analyzer. So I have used this during my BA days. So then BA is acquired by Oracle. So then they renamed that to Java Flight Recorder. And then later, the same code is given to open source. And then now it is the OpenJDK, JDK 11 onwards. Some of the vendors like Azure, Pivotal, so right, they support the OpenJDK builds, and then you can make use of from Azure with their supports Java Flight Recorder. So Java Flight Recorder architecture, if you see that, your the Java Flight Recorder is built within the JVM itself. Okay, so you no need to have any additional jars in the class path. Okay, and then you don't need to specify anything. And your application can make use of Java Flight Recorder if it is running in JDK 1.8 or 1.11. Okay, and you can specify some of the options saying that, hey, how long you want the recording. Suppose if you are running the unit test, the unit test run for 15 minutes, you can say that I want to record maybe first 5 minutes or last 5 minutes, or maybe the complete 15 minutes duration itself. That you can specify it. And there is a UI tool, Java Mission Controller. With that, you can analyze the recorded files. So this slide talk about the differences between the traditional sampler-based Java profilers versus flight recorder. The sampler-based profilers will make use of JVM tooling interface, and then they use the bytecode instrumentation. But whereas flight recorder is built in the JVM itself. Okay, as I mentioned, it doesn't require, there is no agent jar. Okay, typically the samplers will use java.lang.instrumentation package, and then they built the instrumentations using agent jar, and then that needs to be into the class path. So then that jar will make use of, right? They make use of JVM TI call get all state traces. So they have a potentially it encounter safe point bias. So what is the safe point bias? So whenever you make call to thread infos or stack infos, assume like there are three threads are in this particular application: thread 1, thread 2, thread 3. So in order to get the details, so you can request a safe point request. So thread 1 may be completed in one particular time interval, and then it can say that, hey, I am available. But thread 2 is doing some system.array copy and some of the calls. So then it has to wait. The T1 has to wait, right? And then T3 also can respond. So it takes some time for all the three threads, right, to come to the global save point. That is the time to save point. So this much time has to wait the thread 1. Right? It is a stop the world kind of thing. So there is an impact on the performance overhead in some of the traditional sampler profilers, which make use of get all stack traces. Whereas if you use a JDK flight recorder, which comes from the open source OpenJDK, now it is open source. It uses make use of the hotspot internal APIs, the safe point bias, okay, and then it can asynchronously stop the execution of the thread, and then at any point of time. So that's why I suggest to make use of the Java flight recorder for continuous performance engineering, or any profiler which supports async profiling option. So with the Java flight recorder, it can record the file IO, socket IO, method profiling. It can you can make use of it. You can take thread dumps. You should be able to figure out garbage collection and the thread local allocation buffers, as I mentioned. That also you should be able to see it, and then you can see the system resources, the number of threads, etc. And there are 5 different ways Java flight recorder can be used. One is, as I mentioned, that Java JVM argument. You can enable flight recorder -XX plus flight recorder, and then you can specify how long you want to run, and then what is the delay, and then what is the flight recording file name, and then where it has to do. And then there are 2 settings you can do. One is the profile, and then another one the default. In the next slide, I will talk about what is the difference that. And if you are using that, there is the one option. The second option is you can use the Java command exe, okay, the Java command program, and then you can specify the PID, and then you can use the jfr.start command, or you can use the Java management extensions APIs as well. And then you can use the Java machine controller as a tool which can do the live profiling of the application as well. Or if you are interested in API based, so you can use the Java API recording.start as well. So there are two modes. One is the default.jfc, and another one is a profile.jfc. So I recommend default.jfc can be used in the production as well, because that has a lower overhead, and then it collects the minimal information, which are good enough sometimes, right, to find out the root cause. But if during our performance test and then in the continuous performance engineering, use the profile.jfc. So this provides a lot more data, performance data, and then at the same time, it has some overhead when compared to default.jfc itself. And the JFR settings, these two files are available in the OpenJDK path and slip.jfr directory. You can edit, do whatever, which options you want to use it based on your profiling needs. You can change these files as well. So I would like to give an example of application which I want to show how continuous performance engineering helps. Assume like this particular application deployed in Azure. Okay, so there is basically homomorphic encryption. As you know that homomorphic encryption as per the Paler crypto system. Okay, so you can encrypt a message. Okay, and there are two messages. Assume like, and you can encrypt message 1 and then encrypt message 2, and multiply these two encrypted messages and take a mod of n. N is a large prime number, so that is your public key. So that is, and then you can decrypt it. So that is equivalent to the two messages which are not encrypted, the addition of the two messages and mod n. So these are the two properties of the homomorphic encryption. There are a bunch of others are there as a part of the fully homomorphic encryption. And Microsoft also supports a library open sourced it. So that is basically you can make use of the C++ code. Okay. In this slide, I have written a program which is a producer-consumer kind of problem. In one build, so the producer is sending two messages. Okay, assume like maybe 10 and 5. There are two numbers. So the two numbers, you are encrypting it and then sending to a consumer using a blocking queue. In this case, I'm using Java linked blocking queue, and I use there is no upper bound, so that since I've written in an infinite while loop, so the producer is keep on sending the two numbers. It takes two numbers and encrypts it and send to blocking queue. In the consumer side, what I'm doing is in the consumer side, what I'm doing is I am multiplying the encrypted messages, okay, and then decrypting it with mod n square. Okay. Can you see the next screen, Rohit? Yeah, okay. So if you see that there are two builds, okay. In the first build, the producer threads sleep for 500 milliseconds before sending the next two messages. Okay. In the consumer side, it processes the two encrypted messages and it multiplies that, okay, and then decrypts so that you will get the original two message addition itself, and then it sleeps for 300 milliseconds. But assume like in the second build, maybe one of the engineers saw that, hey, why the producer has to wait? Okay, let me change the timing of the producer wait time to 100 milliseconds. And similarly, okay, consumer needs to do a lot more since it is doing homomorphic encryption decryption part. Okay, let me increase the consumer thread sleep time to 500 milliseconds. Just these are the two lines of change. He did it, and then he submitted the pull request. assume like the first build we have the unit test, okay, and then we have the Java flight recorded options. What is the recorded file? And then second build also assume like we have the recorded file. So using Java flight recorder, like if you're using a Java machine controller, you take the live JVM and then you can specify how long the flight recording is to run, and then you can specify the recording option and all. So I used the Java machine controller and then generated the two mission recording files for the build 1 and build 2. So the first build, okay, if you see that Java there are kernels and all. And the next garbage collection comparisons. Okay, if you see that in the first build, it took just 3 milliseconds, some of the pauses. Okay, and in the second build, if you see that there are 4 GC events happened, and the sum of the GCs are 68 milliseconds. Okay, in the first build, only 1 GC event happened, and the sum of the garbage collection pause times is just 3 milliseconds. But whereas in the second, it took 68 milliseconds. So that means something is wrong with the second build code, right? The JVM is taking, the GC is taking more time. And if you see the thread local allocation buffers, in the first build, there is 144 bytes are allocated outside the thread local allocation buffer. As I mentioned that for each thread, there is a TLAB size. But whereas in the second build, all threads are allocated within the TLAB itself. Okay, so this is where you can compare between the two builds. And then memory, right? The live objects. If you see in the first build, there are no live objects, okay, when the GC is happening. Pretty good. But whereas if you see that the memory size, it's keep on increasing it. Okay, keep on increasing. So that means after some point of time, definitely it may come to out of memory exception. And similarly, if you see the live objects count, okay, the live objects are more, and there are live, and then size is also more when compared to the first build. In the first build, you don't have any live objects, so that means there is no memory issue. But whereas in the second build, the memory issues is keep on increasing it. Eventually, it may end up in out of memory exception. Okay, so that is the problem with the slow consumer, whatever the settings he did it. And there are a bunch of VM operations. So this requires a little bit of experience. So, okay, since I'm running just for 5 minutes, so there is a GC heap inspection, the VM operation also triggered. But at this point of time, you guys no need to worry it. Okay, so with that, what we can say that the second build, when you compare these flight recording options, you can reject the build, saying that the second build basically is taking more garbage collection. Okay, the GC amount of time spent is more, and then live objects also increasing it. So you can, right, you can reject the pull request, and then submitter can change the code again and then submit it. So there are other ways of doing the Java flight recording as well. If you want to, if you don't want to use the GUI tools, if you want to make use of your own code, so you can. There are 2 classes are provided: Java flight recorder recording file and recording event. So you can make use of these two classes and process the Java flight recorded file itself. Okay, so the JFR file .jfr file will be dumped. It's in megabytes, depends on the how long you are profiling it. So that file you can parse it and then make use of these 2 classes to get the meaningful data from that. Okay, or you can use the Java machine controller as the GUI itself. With JDK 14 onwards, Java 14 onwards, there is a new mode is supported for the Java flight recording, so you can get the event streams as well. So apart from sending the data into the JFR recording file, it will send the event streaming, right? So that you should be able to listen to a Kafka or something like that. You can send these events to there, and then you can process, and then you can process the rest of the performance monitors as well. So as I mentioned that in Azure, the sample app which they provided with respect to integrating with the CI/CD and deploying in Azure Cloud using Azure Web Apps, there are 3 places you can integrate Java flight recording. So one is with your favorite IDE, in this case IntelliJ. IntelliJ has options to integrate Java flight recorder. And then the second one is the application insights. So you can use application insights and then make use of the JMX and trigger Java flight recording as well. So that along with application insights provided by Azure, we should be able to get the JVM telemetry and application telemetry as well. And the other one is in the Azure Web Apps, whatever is deployed. So there you can make use of, if you're running in a Tomcat or a Spring, so you can make use of the command line options as well. So these are the 3 places. If you are using Azure Web Apps, you can integrate the Java flight recording option and analyze the recorded files. So with that, I would like to conclude. You always make use of the performance profiler with low overhead, okay, and integrate your unit tests early in the life cycle with the profiling things. And if you have a performance test, that is well and good, so that you will have a lot more data is available to analyze, okay, and baseline the application's performance data and compare with each pull request. And some of the checklists you can make sure that based on your organization's maturity, and compare the snapshots of the 2 builds or 2 right, and then only approve the code based on the once the application meets the required performance data. Okay. So with that, I would like to conclude my talk. Thanks a lot. Thanks for taking time. And during this pandemic situation, hope everyone be safe at home and open up for the questions. Thanks again.
Thanks a lot,
Over to
Srinivasa, for
Rohit.
this session. Yeah. So thanks a lot, Srinivasa. I see there are so many questions coming up. So I'll just pop it on the screen so that you can go through them and answer.
Yeah, sure, Rohit. I think we have a 1 minute time.
Yes, yes. So this is the first question from Ankit. Hope you can see the question.
Yeah, can JVisual VM give similar reports to Java Flight Recorder? So it can also give it. Okay, so just you check it whether JVisual VM is a async profiler or sync profiler. So based on that, you should be able to judge whether it has the safe point bias problem or not. Okay, I suggest to compare, and then I strongly suggest to go with Java Flight Recorder because it is open source and then it is available on the OpenJDK as well. Yep.
Okay, so the next question I'm showing. Yeah, so here's the question from Sarvan. Hello, Srinivasa.
So what is the default memory footprint of Java Lambda function? I'm in the serverless computing talk. Hear me?
Yeah.
Yeah. So the next question is what is the default memory footprint of Java Lambda function? I think this question can be answered during the serverless computing talk by one of the Microsoft expert itself. Yeah.
Sure. So with this, we'll wrap up your session, Srinivasa. So our next speaker is already there in the backstage. Also, Srinivasa, like you can go through the comment box and answer some of the questions offline. So I shared the link with you for the live session of YouTube, and you can go through and answer the questions.
Yeah, sure. Thank you. Thanks,
Yeah.
Rohit.
Thanks a lot, Srinivasa, for joining us and sharing your experiences and giving so much insight. Thanks a lot, Srinivasa.
Okay. Thank you, Rohit.
Thank you. So, guys, that was Srinivasa from Visa. Next, we have Sandra from Microsoft. Uh, just introduce her on the screen.
Good morning, everyone.
Good morning. How are you, Sandra?
I'm fine. Greetings from Berlin, Germany, by the way. It's a bit more early here, but yeah, I'm so happy being here.
What's the time there, Sandra?
It's 8:20.
Okay, okay. That's pretty early.
A bit. It's fine. For Germans, we are used to get up early, but yeah.
So how are you doing?
I'm great. How are you?
I'm doing good. So Sandra, right now we had Srinivasa as the first speaker for jCloud Day. Next is you. So uh, really thankful to have you as a speaker. I would give a quick intro about Sandra. So guys, Sandra is from Microsoft and she is part of the developer advocacy team for Java. So Sandra, I would request you to give a quick intro about yourself, what you're doing, and what is your session going to be about today.
Yeah, sure. Let me just share my screen, then I can go right ahead.
Sure.
My presentation. So my name is Sandra Ahlgrimm. I'm here from Berlin, Germany, as we already said, and I'm a cloud advocate at Microsoft. I focus on Java on Azure. So if you're from the community, if you're doing something for the community, you can totally reach out to me and we do something awesome, fun together. And you can also find and follow me on Twitter at @screamhild, or as I said, I'm Sandra Ahlgrimm for LinkedIn. And today we're going to talk about Go Serverless with Java and Azure Functions. So for that, we're going to start with the evolution of application platforms. First, we've all been on-prem, where we had our servers right behind us in another room or in the cellar if we had more servers. And there we need to care about all those things. How do I deploy new code to my server? Who's monitoring my apps? Who has physical access to my servers and who monitors my servers, as well as everything comes up with my apps. So what OS should I use? What needs to be installed in order to make run my app smoothly, and everything like this. I even had to take care about electricity, like what shall I do if there is a power outage, and all those kind of things. Then we went a bit better and used things like infrastructure as a server. There we still had almost same questions, but they were a bit more, bundled. So I had a department or another company who took care about how often should I patch my servers, and is the electricity there, and yeah, all the other questions as well. How many servers do I need? And obviously, there are still the questions about my deployment. So how do I deploy new code to my servers, and which OS should I use, and who is monitoring my apps? Going on from this one, we went to platform as a service. And there we had the questions only like, what is the right size of servers for my business needs? And servers is there with those hypothesizes, as you also could use VMs or containers or whatever. And how many servers do I need, and how can I scale my app, and even how can I utilize or increase my uses of these containers. And the next step is obviously serverless. So there I can really focus, how do I architect my app? Because everything server related is taken care of already. I don't mind which OS is running, as I will only focus on my app, on my code, and make it just work, and then ship it to production. However, it will just work. So serverless is the platform for cloud native apps. Again, what is serverless? We have the abstraction of servers, as I already said, and we are event-driven and on instant scale, meaning I have an event and then I can just scale up on this event, saying we have Black Friday, the traffic is increased largely, so I can just instant scale my code, my functions, my apps, and it will just work. As well as we do have micro billing, which is awesome, because giving that example with Black Friday, I will have a higher usage of the cloud, so I will have to pay more. But, you know, as I have higher usage of my app, I will probably also make more revenue and more money, so I can keep up the cost for the infrastructure as well. But it's also working the other way around, right? So if parts of my app is not used so widely any longer, no worries. At least I don't have to pay that much for my infrastructure any longer, or for my servers or whatever, because, you know, I don't care, as we are serverless. So summing up the benefits, I can really focus on solving my business problems. I don't care about the technology OS. That brings me more efficiency. I have shorter time to market. I have better service stability because, you know, someone else is taking care of my infrastructure. I have better development and testing management, and also important, as we're still, you know, trying to be more green for our environment, we also do have less waste, as we don't need to to have many servers in our infrastructure, and we also don't have unused hardware that much. And we are very more flexible, so I can easier experiment on it. You know, I just try something out with no cost beforehand. I can just do it. We will do it later in my demo as well. And it's therefore also a natural fit for microservices. So let's have a short look at Azure Serverless Platform components. As I said, we do have the Azure Functions. That's also the one I want to demo today. There you can execute your code based on events you specify. We're going to see what events those could be later. And then we do have logic apps. Those are to design workflows and orchestrate processes, you know, among functions and also other Azure services. And there's also something to manage all events that can trigger code or logic. Those are the event grids. We don't go into that in detail today, but I'm going to provide you some documentation where you can, you know, find out by yourself. And those are all bundled in our platform with databases, storage, security, and so on. And it's definitely probably the most best integrated with development suites. So we have the best IDE support, you have integrated DevOps, you can develop locally with visual debug history, and you have monitoring right in place. So let's go right ahead with Azure Functions. As we already said, it's code triggered by events, and this is gonna boost your development efficiency. And that's also, by the way, how our logo comes from, or where our logo comes from. So I said we have different events. So those can be triggers. There you can just use triggers to define how functions are invoked. And this one we're gonna see later on with an HTTP trigger. And then we also do have bindings. So you can also connect your third-party services or Azure solutions like databases. That's also another demo we're gonna do later. And there are even other things like proxies or CI/CD, which is in place, and also the monitoring we talked about. And what I love also is the local debugging. So you don't even need the cloud to just see if something is working, and you can even debug locally your function and connect it to the service in the cloud. So that's also working. So let's go right ahead with the first demo. So here's my Visual Studio Code. I hope everything is big enough that you can see. So I have the Azure plugin installed, and as well as the Azure Functions plugin. Those are the two you will need to do my demo, as well as the Java extension. So I just click on New Function, and I say I want to use Java, and I give it a name, like a jCloud function, a jCloud conf, for jCloud conf. It's a snapshot. So, and as I said, the integration with the IDE is just perfect. So that's why it will just generate everything for me. Oh, and it's already finished. So I can probably already see the code. Yeah, there we go. So what we can see here is a normal Java project. I do have a POM XML where I can see that I'm on Java 8 right now. You can also use Java 11, but therefore you would have to do it via the portal, or you download an example from GitHub and then uploaded it here via Visual Studio Code. And I also have the dependencies for Azure Functions here, as well as the test dependencies, because also the tests are generated. So here I do have my HTTP example. You can see here that it is an HTTP trigger by request. You have the methods get and post. Everyone can use it. It's anonymous. You could also specify here another authorization level. But for this short test and example, that's one should be all you need here. And I can even have a logger, which is very useful for local testing and debuggers. And here I just pass a query name, and then I could see hello and name. So what I can do here, can just start debugging and run this function locally. We also run the tests. And what you see here is a bit kind of a cold start. So if I do it the next time, it will be way more fast. And that's kind of the same you will experience also in the cloud. But in the cloud, obviously, the hardware is probably better than on my local machine here. So it's a bit faster still. So here I have the link. I can go on now. There we go. So it says, please pass name a string. And as you specified, and say name jCloud.
Sandra, sorry to interrupt you. Could you please increase the size?
Even more?
Yeah. Yes, now it's good.
Okay. So I just passed the query string that might be a bit small here. Sorry for that. Okay. So I can see here, hello jCloud, or Sandra, or whatever you want to see here. Thanks for the feedback. 8. So, and we could also do a breakpoint. And yeah, as we said, we also have a logger here, so I can also see all the request details here. Is that big enough, or should it be still bigger?
Sandra, this one as well, because people are not able to see.
Sorry, I didn't got it.
Yeah, so participants are not able to see the font.
You can't see Visual Studio Code, or is it too small?
This one, the studio code.
This one is what?
The studio code, the people are not able to see. So could you increase the size?
Yeah, sure.
Yeah, sure. Yeah, they should be. Thanks.
All right, perfect. Thanks for saying that. Otherwise, it's just useless. So again, we do have the HTTP example here, which can be triggered by an HTTP trigger, and then gives me a logger even. And here I have my answer. That's why we saw here the hello and the name thing, which I passed already here. All right. And no worries. This one was all generated. So if you're following the exact same steps, you will have the exact same outcome. So you can just try that by yourself afterwards. So let's talk a bit about Azure Cosmos DB. I would not go into too much detail here because we don't have so much time, but no worries. I provide you with a great link to another resource for it to have it more in detail. Everything you need to know is that it's a NoSQL database. So you have an elastic scale out of storage throughput. You also have guaranteed low latency, and we also have well-defined consistency models. As I said, it's NoSQL, so we have a key value store. You can use column family, you can even use GraphQL or document storage. And what's the best about Cosmos DB, in my opinion, is that it's working with different APIs. So you could just stay with your MongoDB if you have that in place, or you go with SQL and Azure or Cassandra. But this time we're gonna look more into the SQL part, as we just announced that you could also use Azure Cosmos DB serverless. So you only pay for what you use, but as it is still in preview, it's only for SQL enabled. Yeah. And as I said, Azure Cosmos DB is fully managed, it's globally distributed, it's turnkey, it's designed for massive scale, and it's guaranteed low latency. So it's perfect for our serverless environment and for the testings here. And then in order to create and add a Cosmos DB, I will just go on my Azure portal. Can you see that, or should I do this live as well because it's too small? Okay, I assume you can see it if nobody's answering. So I just go here and search for Azure Cosmos DB. I choose my subscription over here, specify a resource group, and give it a name. And because we want to use the serverless preview model, we can only go with the core SQL API. And I also recommend only use it for non-production, as I said, it's only in preview. So don't go ahead and just put it into production. But as we said, we just want to test and try things out. That's the perfect example for it. And after we initialized and did our deployment, we will also have to add a collection here to use that later in our Azure function. This one was pre-recorded because otherwise we would have to wait here for 5 to 6 minutes. So I shortened that up a little bit. Yeah. And then I can go to the resource, and it's just going with the quick start. And here I can either just click on create an items container, or I go with the data explorer. And once it's connected, I can see here the to-do list. That was the items container I just created by clicking on this button. And I will just create a new container with a new database ID, which is going to be like my database. Container, and just call it my container. And partition key is very important. That's the logical resource where you can find your key values in the data, which can also be in the JSON format. So, perfect. Should be created shortly. go. And now I can see here my items, which I just created. Great. So let's go in and change our functions a little bit, because this one was an HTTP example with an HTTP trigger. And now what I want to do is just copy paste another example, which is probably the most simple version of a Cosmos DB processor. It's a Cosmos DB trigger, and it's triggered by items. So whenever I do a change in the items collection I just created, it will log that here in my functions app. So it's really super simple, not really real world use case, but you can use that and go ahead and go on with that one. Okay. So what I also need to do to make it work is, as I don't, usually you should, adapt the test and do it again, but that should be fine. And I also need to specify the local settings JSON. Obviously, it has to be connected to my database in place. So I just copy it here. So I will use development storage and then add here my database with the secret connection string, and I'm using the functions worker runtime Java. So I have that in place. I can go ahead and run this function as well. And in the meantime, let's go to my Azure portal. And go to the Cosmos DB. There we have talked about the Data Explorer. I hope it's big enough. And here would be my database with the items. And if I create a new item here, which is gonna be 1, 2, 3, 4, 5, and save it, I should be able to see it in my function. Yeah, there we go. So that was really fast. And yeah, here's the item I just created in the functions DB. So that was really quick and awesome. You can just go on from this. You can do it like almost everything with functions. You could also, write a function which would enter the entry in my Cosmos DB. So it also enables me to go maybe from big monolithic applications towards microservices, because I could just create a function which is probably listening at one SQL, probably the MS SQL or whatever I used in my monolithic application first, and then watch there the entries, and then put it into a NoSQL database and go on from there with another function which might do something with the event, like deserialize or use machine learning to get even more out of my data here. So I'd love to talk even more about it, but I think my timing is running. So yeah. What is Azure Functions? Again, it's the best of function as a service. You have the integrated programming model. You have the enhanced development experience. And by the way, if I want to publish this one to Azure, it's just another click from the portal. I could just go here and upload my function, the one I just created, and then it's uploaded there. So it's really easy and very awesome. And I also have the flexibility in choosing the hosting option. If I create a new function on the portal, I have to select if I want to go on Linux or Windows, but actually I don't care, because it's not worth the thought, because everything is working exactly fine the same way. So serverless is enabling me to focus on code, not on plumbing. I have no infrastructure management here. I can auto-scale based on my workload, and I don't waste resources because I only pay for what I use. And also for the environment, we only need to spin up what customers and what we all are using. Functions as a service programming is at the center of serverless. So you keep in mind that you should follow the single responsibility principle. So every function should just have one single responsibility. If you need more, then you have more functions and you connect them via logic apps or via other triggers. And they are short-lived. So usually a function has just one purpose, like copying data from one database to another, or other examples, maybe get the temperature of my IoT device and just put it into an event grid or into another storage. So, and then it's gone. There's no state in my function. So all functions should be stateless because they can't hold any persistent state. And that enables them to be event-driven and scalable. So they do respond to predefined events. They're instantly replicated when you have more events. So at any time you need them, we can just scale them up and down if you don't need them any longer. So that brings me to your homework. You can just go, I said, you always go as with the payment as you need it, but everything I showed, you can even have it for free. You can just click on it, and because you can have 5 GB of Cosmos DB for free, and Azure Functions are also free until you reach a certain level. And so just go ahead with your side project and do that. And there's also the documentation for Azure Functions. So if you want to create a short Azure Functions, not everything is generated automatically as we had it here. So go here, and there's even a more complex example, which is under AKS/MS/homework. I totally invite you all to do that. It's gonna connect your event grid with Azure Functions and Cosmos DB. So you're already set up. You probably have this idea in mind you always want to do. Just do that. It's super simple here. You can probably achieve that. And if you need any help there, go connect with me and we can do that together. And if you did it, put it on GitHub and send it to me on Twitter, then I can cheer for you and look at it. And yeah, I'm really looking forward to your thoughts and how it's going for you. Thank you very much. Are you still there? Stream chat?
Yeah.
Great.
Thanks a lot, Sandra, for the session. I hope there was not any hiccup because, I think initially people were not able to see some of the forms, but I think it was fine.
Yeah, if anything, I will also post it maybe on DevTO and then.
Yeah. And also we have your slides, so we'll be sharing the link and people can definitely go through it.
Yeah, sure.
Yeah. So Sandra, I'll just go through the comment section if there are any questions for you.
Yeah. The partition key is the secret key of your Cosmos DB. I might show it shortly. So I have here my Cosmos DB, and there should be keys. So my primary connection string. That is it, what you need.
So guys, please post a question in the comment box so Sandra can answer them.
I love that view.
So Sandra, are you showing something? Because you're...
No.
Okay. So, yeah. So Sandra, as of now, there are no questions, but I'll share the YouTube live link with you. So you can hop in there and answer some of the questions offline.
Yeah, sure. And you, as I said, just go and follow and ping me on Twitter. Then I can also answer questions there.
Yeah, we'll share your Twitter profile and people will go there and reach out to you and pose their questions.
Thank you very much.
Thanks a lot, Sandra, for joining us today and sharing your insightful views and knowledge on Java and cloud. So thanks a lot.
Thanks. Bye.
Okay, bye. So guys, that was Sandra from Microsoft. Next we have Rory. Before that, I'll like to show the learning resources and about the Azure Dev Challenge to all of you. So guys, we have the learning resources for jCloud, and you can find all the relevant contents on Java and Cloud. So we have already shared the link in the comment box. We'll share that again. You can go through the documentation for Azure for Java developer, and you can use them. So it's a really good digest of all the Java developer documentations, and you can definitely go through it. Also, guys, we have a very exciting developer challenge. It's called Azure Dev Challenge. You should definitely go and participate for it. And you can also earn a Azure Hero Badge. So what you exactly need to do is go through any of the Microsoft Learning Path, which is here. So there are 4. And you can complete them. After completing any of the learning paths, share your MS Learn profile and achievement badge with hashtag jCloud Day. So hashtag jCloud Day is the official hashtag for this conference. So share it on Twitter, and afterwards subscribe to the Microsoft.source newsletter. So Microsoft.source news, if you register, subscribe to this, you'll get the monthly digest of all the relevant technical contents and the events, training, conferences, meetups, everything happening nearby you. So this is a really good monthly digest. You should definitely subscribe to it. So after doing this, definitely some of us will be reaching out to you, and you will receive the Azure Hero Badge. So guys, without wasting much time, I will add Rory to the stream. Hey, Rory.
Hi, everyone. I'm guessing that I'm live. Just tell me when I can start, and we're going to do 30 minutes, and I'm going to teach you microservices.
Awesome. So how are you doing, Rory?
Yeah, it's nice. This climate is different, the COVID climate. And, you know, here at Microsoft, we are empowering developers in every organization to do more. And one of those is with Java. So my colleague, Sandra, did an incredible talk on Azure Functions. And I'm going to show you how to take that Azure function into a microservice. And in 30 minutes, you're going to know how to do microservices.
That would be awesome, Rory. So shall I put your screen on stream?
Yes, please.
Sure. So Rory, going further, you can give a quick intro about yourself, what you're doing, and what this session going to be about. So I hope you will be giving a demo on that.
Yes, I am, a live demo. Hopefully it'll work. You'll see here, I'm going to spin up a Kubernetes cluster, Spring Azure Cloud cluster. So a lot of moving parts, and let's see how that goes.
Awesome. So here you go, Rory.
Great. So hi, everyone. My name is Rory, and I work in the developer relations team at Microsoft as a senior cloud advocate with Java. You've already met my colleague, Sandra, and we empower organizations around the world to be able to use the Azure platform to achieve more. So let's set the stage. So Spring's flexible libraries are trusted by developers over the world. And you can see here from the latest SNCC report that a significant number, 50%, indicated that Spring Boot is their framework of choice. I guess most of you are actually using dozens, if not hundreds, of microservices and Spring Boot applications in production today. However, business is growing, technology is evolving, and distributed teams are changing. Companies are looking to become more agile so they can innovate and respond to change faster. And we've seen now with this COVID climate that remote development, remote distributed teams is the new norm. In large distributed projects, we firstly need to let each team independently build, verify, deploy, and monitor their services. Applications need to scale quickly to potentially millions of users around the globe. We need independent services that can be scaled based on their respective demands. We will also need more efficiency through end-to-end development experience, coding, debugging, deployment, monitoring, and management with integrated tools and DevOps. And finally, then we have a chance to achieve reliability and faster time to market. To achieve these goals, today I'm going to be explaining how to build your services independently and run them globally. We'll see how you can scale your services and manage the app's lifecycle efficiently. And then we'll discuss how to deliver these values faster. Microservices are a software architecture style in which applications are composed of small, independent modules that communicate with each other over well-defined API contracts. Each service is a highly coupled building block that is small enough to implement a single functionality. A typical microservice architecture consists of a collection of many of these small autonomous services. Besides for the services themselves, other components appear in a typical microservice architecture. First of all, we have management and orchestration. These components are responsible for placing services on nodes, identifying failures, rebalancing services across nodes, and so forth. We then have an API gateway. As you can see from the diagram, we have many microservices which expose external APIs to clients. In real-world systems, this number can grow very quickly, as well as the entire system's complexity. Usually, a much better approach is to use an API gateway. We've discussed the building services independently. Next, how can you actually run these applications globally? It's quite easy to get most of the value out of the cloud. You can use the many data centers that Azure has in different regions worldwide. Now, I've got a plan. I'm going to show you how to build cloud native microservices and to leverage off the Azure global data center footprint. Part one can seem difficult. I have dozens of microservices. How do I design them for the cloud? So let's start. To achieve this, we're going to use Spring Cloud as our platform. Spring Cloud provides 4 key services necessary for our microservices. A Spring Cloud service registry can help by enabling client-side load balancing that decouples our services from its consumers without the need for a DNS. Next, we have Spring Cloud Config, and this is designed to ease the burdens and off integration with versioning control systems like Git. Next, we have Spring Cloud Sleuth, and that instruments my application in a predictable and repeatable way and gives me access to see the logs for my distributed application. And finally, we have Spring Cloud Gateway, which gives me precise control over your API layer, integrating Spring Cloud service discovery and client-side load balancing solutions to simplify configuration and maintenance. In short, Spring Cloud can help me, as well as you, build cloud-native microservices easily. So let's see how we can take this configuration and connect it to the many back-end auxiliary systems that you have in your typical environment. There's actually an easy way to seamlessly integrate with these rich assortment of managed back-end services. Instead of owning the service, you simply consume it. And if I want to use them, but I don't want to add them with a lot of Azure-specific code, you can achieve this by using Spring on Azure starters. These are open source libraries that further simplify connection and consumption of Azure managed backend services under the Spring framework. They give developers a Spring idiomatic way to connect and consume Azure services with only a few lines of configuration and really minimal code config. Next, we have our ecosystem. In this ecosystem, you can find so many different Spring offerings: Spring Cloud, Spring Data, Spring Relational, RT2BC, Spring Security, Cache, Resources Messaging, and Micrometer projects. Let me share 2 examples here. So, and these are your Spring integration starters. Azure Cosmos DB is a globally distributed database that Sandra just demoed that allows developers to work with data in a variety of standard APIs, SQL, Mongo, Graph, Table APIs. The Spring Boot starter for Azure enables developers to use Spring Boot applications and easily integrate with Cosmos DB by using different APIs within a Spring idiomatic way. Next, we have Spring Key Vault, which can be used to easily store and lightly control access to tokens, passwords, certificates, APIs, keys, and other secrets. And you can see from this ecosystem here, we provide Spring integration libraries in an idiomatic way for nearly all of those ecosystem requirements. Great. So we've decoupled our application with microservices. How do you scale them based on their respective demands without impacting the overall performance? We've already introduced the concept of orchestration earlier. Typically, this component is an off-the-shelf technology such as Kubernetes. Kubernetes orchestrates clusters of virtual machines and schedules containers to run on them based on the resource requirements of each container. It is the platform I'm looking for to really manage and scale my microservices autonomously. And this is the platform that we're going to focus on for the rest of the talk. This is a workflow that you see in this diagram to illustrate how Kubernetes rolls out work. But it seems I need to understand a lot of moving parts like pods, schedulers, YAML, and how to open different services. It's not an easy job to manage Kubernetes by myself. Besides Kubernetes management, how do I take care of the end-to-end application lifecycle from deployment, scaling, and monitoring? As you know, the most challenging part for an ops part of microservices is the whole system, including Kubernetes, JVMs, Tomcat, Spring, and keeping the business continuity going. So introducing Azure Spring Cloud. So Azure Spring Cloud is a fully managed platform as a service, and it takes care of the patching. It also offers custom domain data encryption and other capabilities for enterprise-grade capabilities. It takes the headache out of Kubernetes. To manage the lifecycle, more things I need to do on my daily work. We have dozens of microservices, CI and CD pipeline, and automation. And we have to have these to be able to really fulfill that enterprise contract. Azure Spring Cloud offers me these in an Azure CLI, PowerShell, ARM template to automate the resource provisioning. It also offers Azure DevOps in GitHub Actions and Jenkins, as these are the most popular tools. You can see here from the diagram, it has a lot of other integration features here that allow me to really take the hassle and the headache away from Kubernetes management. We also have the ability to tie into the build service, the Azure Spring Cloud build service. And let's have a look at exactly how we can manage to do that via the connection of our CI/CD and our automation platforms. We'll also look at how to do distributed tracing with Azure Monitor, and then finally also look at integrating with Azure Active Directory. So besides CI/CD pipelines, Microsoft also has partnered with Pivotal to bring you Maven and IntelliJ plugins to deploy your applications to Azure Spring Cloud in a few clicks. It supports both FATJAR and source code, and it has built-in VM Tanzu build service that uses cloud-native build packs to build container images. We're going to do that in the demo from source code. So let me just show you a brief introduction of how to actually use that VMware Tanzu build service. So here's cloud-native build packs, and this was introduced in Spring 2.3. And what it does, it actually analyzes your project and creates a custom Docker image based on some AI algorithms that would make your image really shine in cloud native. So we're creating from our service, our microservice, into a cloud native platform that allows us to really go and deploy this into our Azure Spring Cloud cluster. Now, what I didn't tell you is that Azure Spring Cloud actually runs on top of Kubernetes, and it obfuscates that requirement to understand Kubernetes. And we're going to do that a little bit in the demo. Then I'm going to show you how to create your cloud native build pack. So as you can see also from this distributed tracing, we've given you also out-of-the-box support for integrating logs, metrics, and distributed app traces into Azure Monitor. So you can easily visualize how applications are performing. In the demo, I'm going to show you how to do that. I'm going to create a bug, and then we're going to try and find that bug via distributed tracing. You can also isolate potential problems to individual services. Furthermore, I can set alert rules that are important conditions like request counts, CPU usage, and then I can identify and address issues before users notice them. So let's see how to support multiple teams that work on different services at the same time and put these features into production. This is the final part of the presentation, and then we're going to do the demo. So Azure Spring Cloud leverages the power of Kubernetes. It runs on top of Kubernetes using as cloud native build packs to orchestrate your microservices. It abstracts away the complexity of infrastructure management and offers pre-configured Spring Cloud components and ready-to-deploy environments. So your teams can focus more on building business logic for each service independently in parallel, and let Azure take care of the rest, such as dynamic scaling, security patches, compliance standards, monitoring, and high availability. The good news also, it's jointly built, operated, and supported by Microsoft and VMware. And that is Spring Cloud running on Azure, backed by Kubernetes using cloud-native build packs. And it's a lot to take in, but I'm going to show you the simple demo that I've got that is going to allow us to take that next step in building your services. And I'm going to come to my PC, and the demo is pretty simple. I'm going to create a to-do application. It's going to use build packs to build a cloud-native image, deploy it to Kubernetes, and then I'm going to show you the same process using Azure Spring Cloud, so you understand what it does in the background. And then I'm going to demo distributed tracing, the registry, API gateway, and I'm going to do blue-green deployment to fix the bug that I'm going to show you that I have. So I'm going to get out of my slides, and this is always kind of scary when you get out of the slides. You don't want everyone to see your PowerPoint presentation. And then I've got my terminal. I've got Visual Studio Code. I'm going to make it a little bit bigger. Is this the nice size? I know that the StreamYard might be a little bit too small. This is a nice size here. Now, kind of set up my application beforehand, and the easiest way to set that up, I'm going to go into Chrome, is I've preset up, where is my Chrome? Actually, I can just open up a new window. It's the nice thing about scripting everything else. So I'm going to initialize. I'm going to show you how to initialize your application. There's my Chrome. There we go. New window. Here we are, Chrome. I'm going to make that a little bit bigger. Options. We want to go zoom. And let's make that bigger. ++++++. Cool. Now you can go to start.spring.io, and I've already kind of initialized that. And then I've set it up that I get and for this demo, we're going to use an H2 database, Spring Reactive Web, and Spring Reactive R2 DBC to connect to our reactive database, and then create a RESTful services using the reactive paradigm. Then you just go generate, and it's going to copy a zip file, which I've already kind of set up. And then in that zip file, then you're going to get a config like this, where you're going to have your source folders and an empty application of properties, and then you're going to have a POM file here with all of your properties here. So we're gonna just delete all of that, and I'm going to show you how to actually create it. So first thing I want to do, I want to clean that up a little bit, because I want to create 2 profiles to run in the cloud and run locally. So I've set everything up beforehand, and I've got my POM here. Let's just go through that briefly. And I've got my coordinates. I've got I'm going to use 1.8, Java 1.8, Azure Cloud 2.3.1. And then I've got my dependencies. I'm going to use RTDBC, Webflux. I've got my H2 runtimes. I've got JUnit. And then I've also got my dependency management for my versioning. And then I've got some also dependency management. and I've got a cloud platform. So when I want to run it locally, I don't want to bring in all my dependencies here. And the cloud platform is pretty simple. I've got cloud config, Sleuth for distributed tracing, Zipkin also, Eureka to manage the registry, and then finally also I've got the cloud starter, which really kind of lets me connect to my Eureka client. So that's my POM done. Let's create our reactive to-do microservices. And I've really kind of scaffolded out the empty classes here. I've got my application, I've got my to-do class, I've got my controller, I've got my exception if I can't find it, and then my repository. So we're going to create our little to-do here, and with the power of snippets, I'm going to show you how to do that live coding, semi-live coding. And I'm going to go jCloud, and I've got to-do here, and the to-do application here, the DTO, just has an ID, a title, completed, and it binds really to the table to-do. Pretty simple. Then afterwards, I've got my to-do repository. I want to pull those to-do items out of my to-do repository, and I can do that with the power of semi-live coding, and I can go repo. And this is a pretty simple repository here, and it just goes public interface repository, extends reactive CRUD repository. I've got one little method I've added here, find by title, which just says select star from to-do where title equals to title. And that's how you do reactive repositories. It's as simple as that. Once I have that, I want my not found exception. So I go jCloud, and I must actually keep times on the time here. jCloud exception. So now if I can't find it, I can actually create my to-do not found exception. Then I want to actually create my controller and my RESTful services. I'm going to create my controller, and this controller is pretty simple. It has, and I've hacked it, and this is the bug that I'm going to introduce, cross origin, and I'm just allowing anything there. This is a really big security risk, though, to allow everything. I've got my request controller that injects my repository, and then I've got some methods here, get all, get by ID, add to do, update, you know, your general your CRUD actions. And then finally, I want to do my main method here, and I want to create my, no, there we go, a jCloud app. My main method here really kind of shows you what we're going to do. The first thing it's going to do is going to create the table if it doesn't exist. And this is just a Spring Cloud application here that runs the command line runner. It's going to create the table if it doesn't exist. It's going to delete and refresh it so we can start again. It's going to create a stream of objects that I'm going to insert here, of to-dos. I'm going to save them all. And remember, every time that you use reactive, you have to block or subscribe. So I'm going to subscribe there. And you can actually mouse over there and you can see how to use reactive systems there. Then I'm going to use find all. I'm going to find them, find by one, find by title, and then that's everything that I'm going to need in my application. So this should all run. And the nice thing about Git is that I can actually check if I've added anything or removed everything. So let's just go make sure. Yeah, that's fine. The POM, that's fine. So let's run that now. Now that I'm happy with the application, and I just run this, and I'm running this locally without any cloud engagement. I can just go run and debug. If the demo gods are great, then it should. And it's going to connect to my database. It's going to insert my to-dos. And then it's going to create my RESTful services. And it was quick because it's an H2 database. So now you should see my my RESTful services here. And I can go to a localhost 8080, and voila, I have my to-dos. It's as simple as that. I've created a reactive application. Now let's go and create a cloud native build pack of that same application. So now I've got my little terminal here. And the first thing I want to do is I want to get my install my cloud native build packs, and I've already installed it, but to do this on a Macintosh, you just go paste brew install build packs and tap build pack. It's pretty easy. And then I've got the ability to run pack, and I'm going to now take my application and I'm going to build it into a cloud native build pack. And you'll see here, I'm just going to paste that in here. I'm going to go pack build builder, and I'm going to use the Alpine builder, Alpine Linux. I'm going to call it this Rory Preddy Spring Cloud and pop it into Docker Hub, and then I'm going to make it verbose so you can actually see how that's working. And so this is going to create my Docker image locally and also in my my Docker Hub repo, and I'm going to push this into my Kubernetes cluster. It's as simple as that. Now you can see here, it's going to analyze my project, and it's going to say, wow, okay, cool. These are the libraries I'm going to use to analyze it. It's got Java, Kotlin, and all of these things. It's pulling them array, and luckily I've already got the layers done there, so it shouldn't take too long. Detecting, it's going to find out what the layers are, and it really did that there. It's detecting Java, and it's detecting Maven. You can see there, Java pullback, installing JDK, building Maven, and adding the different layers onto my build pack, my cache layer. You can see there, it's adding the Java, Maven, the JDK, the actual application that I'm going to run, and it's done. I've just built a cloud native build pack with all of those images, and I can go Docker images, and I can find that image. So Docker images, and if I can find it, Docker images, inspect, and we want to go Rory, Preddy, and / going a little bit off script here, Spring Cloud. You can go and inspect those. Yeah, it doesn't like the inspect. Let's just go Docker images. Let's go Docker images there. And you can go inspect it, and you can see all the different layers. And then I've got my layer there. Now I'm going to push that to Docker Hub. And you can push this to your ACR registry, your Azure Container Registry also. But I just find that it's simpler if I just go Docker push, and then I've got my Spring Cloud registry. Just want to make sure that I'm on time. Let's go into PowerPoint. Well, I can't actually see the time. Where's the time here? Yeah, I'm still really much in time. And it's going to pull those actual layers down, and then I'm going to push this to my container registry and run a Kubernetes cluster from this. Yes, I know, I am brave to actually do that. So I've pushed it to my registry. I've already logged into my Kubernetes cluster, and you can see that by going into Docker, and you can see Kubernetes have activated, and I've already created a Kubernetes cluster. And I did that with the DevOps starter. You just go into Azure DevOps starters, go create a Kubernetes cluster, and I'm just using that off there. So I've set my account already. Now I'm going to go and I'm going to delete everything. This is really brave. kubectl. I'm going to make sure that everything's clean. Delete deployments and -- all. I'm going to delete everything there, and then I'm going to go kubectl delete services. Yeah, okay. It had it running, and then I'm going to go delete services. This is so brave. Services -- all. There's nothing running on my Kubernetes cluster. And this is running in Azure right now. So kubectl get all. You can see that there's absolutely nothing running on my Kubernetes cluster, no resources. So then I'm going to create my deployment that in my Kubernetes cluster from that image in Docker Hub. And I'm going to go kubectl create deployment demo. We're going to call it demo. And then I'm going to use the image that we just created, Rory Preddy Spring Cloud. Done. So this will actually do that. It will take a few seconds actually. And then I can go kubectl get all. And it should actually show me that my deployment is created. Great, it's saying container created there, and we can wait for that to get created. Hopefully it does create. Container created, creating. While this is working, container creating, we're actually going to go create our services there. So I'm going to go kubectl create service, and I'm going to give it a cluster IP because I want to really expose that to the world internet. And then I'm going to say demo and bind to port 8080 and have the external port 8080. So that's going to create my service. Demo created. That's great. So now I can go kubectl get all. This is so brave. Sandra, if you're watching this, just understand that this was really well rehearsed before I actually did it. And it's got the Kubernetes cluster, and it's busy creating that container. Remember, this is inside Kubernetes. And then finally, also, I'm going to actually go in and create my port forwarding and bind to that port. And hopefully it will be ready by then. Else we can start the next part of the demo and come back to that. So I've got port forwarding and my services, port 8080. It's going to randomize, unable to forward the port because the port is not running. Okay, so let's give it a few seconds, and then let's wait for it to actually run. let's see here, get all, container creating. Let me just make sure I'm in the right subscription also. Should be in the right subscription, paste. Yeah, that should be that. Okay, well, once this is running, let's go back and actually see how to do this now, this entire process with Azure Spring Cloud. And you're thinking, you know, there must be so many different actual steps. So let's wait for our cluster to come back and let's go do this in Azure Spring Cloud. Now I've already created my Azure Spring Cloud. So if I go to my portal, I've created my Azure Spring Cloud. And it's pretty simple to go in and check your Azure Spring Cloud config. And I'm using a pretty simple configuration. And I've got my to-do application. I've also got a, let's find it there, Spring, and I called it Spring 1 demo because I'm doing Spring 1 soon. Spring 1 demo, and I've got my apps that I've already created, and I've got my to-do app ready for me and waiting for me to config. And then I've also got my gateway. So this was just a cloud gateway that we've that I've deployed before, and I can go into my terminal now, and I can run the command that we can actually go in and run the exact same services, cloud native and Kubernetes cluster creation, and it's as simple as that. All I'm going to do is just run this command, and we can go through the command, paste. I'm going to go AZ, which is your Azure command, Spring Cloud app deploy to do, and that's the actual name of the Spring Cloud group. Resource group, I've already given the resource group, the jar that we've created from the project, and done. It's going to take about a few minutes to run, so could not be found. Oh, I need to log into my other resource group there. Yeah, let's go there, and we want to log in to our different subscription because we didn't have that. So I'm going to log in, set the account to that subscription. So this is what happens when you run in multiple subscriptions. You kind of lose track of where you are. So let's actually go into that subscription. And I want to go and I'm going to set my subscription. This is also a nice way to show you how many subscriptions advocates have. Let's go set that. Okay, got my subscription, and now I'm going to actually do the same command there. And now it's going to actually take a few minutes to run. And we, while that's happening, we can actually go in and see our Kubernetes cluster if everything according to the demo ran accordingly. So I'm going to create a new terminal here, new window. Let's make that a little bit bigger. And let's actually go kubectl. Let's go into the different, I'm going to go into my different subscription. I'm using 2 subscriptions at the same time. Set the subscription, and then it should actually create. All the demo guards didn't shine too brightly on me. Get all. It's still creating the container. There must be an issue with it, but it doesn't matter. I'll show you how the demo actually works, but it also shows you how difficult it is to actually create Kubernetes on the fly though. I don't know why the Kubernetes cluster didn't work, and for me to go in and find out those that log would be really difficult. Whereas with Azure Spring Cloud, it does all of that for me, and it creates the cluster for me with that image that I created from the jar file with those cloud native build packs. Now, I can actually go in and show you how this looks. Let's go in there, because I've got a blue-green deployment. So in my apps, in my to-do application, I've got 2 apps. One is you can see here, let's go to deployments. Let's make that a little bit bigger. Let's hide that. How am I doing for time? Should be still plenty of time. So I've got my to-do application here, and I've got, let's go bigger. Plus, there. So I've got my to-do application here, and I've got my green deployment and my default deployment. Now, the default deployment is the one that we're deploying right now, which is going to take a while. The green deployment doesn't work. So if I go into green, you can actually see here that I can browse the application, and I've built this with a little bit of a bug in my app. And I'm going to show you how to actually swap that over to be able to use microservices. So let's just wait for that to complete. There, it's completed. And I should be able to go now into my application, my default application there. Let's go find that URL. Actually, I can just go here and I can go to do. And I've got my Spring Demo Gateway services to do. And I can hit enter there, and it should actually, there we go. And the demo is deployed. And I did that live. And what this is doing is using To-Do backend to get my to-dos in a nice way. And I can go buy milk. And there is a bug in here, which I have noticed, because it's reactive, the To-Do backend doesn't like it. I can't actually delete it. We're going to try and fix that bug by doing a blue-green deployment. And this is actually using our gateway to isolate the services here. You can see their gateway, and we're not using the live URL. So I want to do a live blue-green deployment. Let's go to do. And all I have to do to swap it over, if I have a bug on my deployments, I just click on here, and I go set deployment. And then I'm going to go in, instead of green, I'm going to go to default and hit apply. And it's going to go roll that cluster for me, find the nodes, do all of that enterprise services for me. And this is really the demo that I wanted to show you. One is I showed you how to create cloud native build packs, how to create a reactive to-do application. Then I pushed it to Kubernetes, and the demo gods weren't happy with my Kubernetes cluster. And it shows you how difficult Kubernetes really is to manage. And then I did the exact same with one command with Azure Spring Cloud, popped it over there, got my registry working, got my services ready, and let's carry on with the presentation. The final bit that I want to do with you, present to you. Let's see how much time we also have, and we can take in some questions. You should be able to see my screen, and yeah, I'm good for time. So in this demo really was to create the to-do application. So we've got some great links that we can show to resources to help you getting started. First of all, you can use your Azure account right now to start with Azure Spring Cloud today and leverage the expertly maintained Microsoft Docs references. Then integrate with Azure Spring Starters into your projects to introduce Spring idiomatic Azure libraries. And finally, spend some time, quality time with our workshops to get detailed experience with Azure Spring Cloud. And take the survey that we have there, the QR code. We listen to your feedback, really, and you can access all of these. I'm going to leave this on here, and then I'm going to take your questions. So please, organizers, if you can give me some questions, and then I'll leave this on here and take your questions. Do we have any questions?
Yeah. Awesome, Rory. So going through the comment box, if there are any questions. So people are asking for the link to your code, so that we'll be sharing.
Yes, so all of the code, including how to start and also run more detailed microservices using distributed, is in the links that I'm sharing right now. So get started with Azure Spring Cloud. So you can go aka.ms/Spring Cloud Docs, and you'll get there first a Hello World application on how to get started using reactive microservices, and then also a more detailed one on how to actually create your gateway, your config, your distributed tracing, and all of that is via the links that I'm sharing right now.
Awesome. So Rory, I see there are a few questions coming up. So I'll be sharing them on the screen so that you can see.
Okay, so let's go off the slides there, and let's go into the screen. I'm going to maximize that. I'm just going to leave the screen here also so you can still see it. Okay, great. Okay, so when should you use Azure Spring Cloud over Azure Kubernetes services? You saw there that I practiced this demo 100 times, really, over the last few days. My Kubernetes cluster didn't behave. I don't know why it didn't behave. For me to go into the logs and to work that out is pretty difficult. So the question rather really is to, you're using Kubernetes cluster with Azure Spring Cloud. That's really what it is. It's using it underneath there, but it's taking away the need to do that. So where you would use Azure Spring, Kubernetes cluster, if you really need tight and low-level control over your Kubernetes cluster. Most of us don't need to do that. We're Spring developers, we're Java developers, we use microservices. We want to actually just go create our services and then push them into the cloud. Next question.
Sure. So I hope. Yeah. So here's the second question from Suman.
Is Azure Free Cloud sufficient to run these exercises? Yes, it is. So you'll see there that you can actually run all of this in Azure Spring Cloud. And of course, at the end of the docs, we say delete your resource groups. So as long as you don't run your resource over the necessary, like over a few days, so complete the lab, do the workshop, delete your resources. Make sure that your resource group is deleted, and then it shouldn't charge you really. And that's the nice thing about being able to do this really in a lab environment, that you start up your Spring Cloud. You saw there that I did all of this and I created my cluster and all of that. It took me another half an hour to actually create all of that. So within the space of an hour, I could have done everything that I did and also use my free tier to run this. But first start on the build packs, the cloud native build packs, getting to know Kubernetes, getting to know how to build Spring microservices. Look at how to actually create a reactive Spring application. And then once you do that, then go into Azure Spring Cloud. Remember, Azure Spring Cloud is to take the headache away from Kubernetes and allow you really to leverage off the power of cloud Kubernetes clustering without really the worry about that maintenance.
Awesome.
Next question.
So there's a feedback from Gaurav.
So it's a good demo to stitch, consider it into one situation. How about Circuit Breaker? So Circuit Breaker isn't actually being maintained anymore. Resilience for J is the new library that Spring recommends that you should use. So if you are using Circuit Breaker right now, please have a look at Resilience for J. And the good news is that we are going to cater for Resilience for J in the future roadmap of Azure Spring Cloud and Spring Cloud in general, though. Stop using Circuit Breaker. It's not maintained right now.
Okay, so we have next question from Dev.
Rory, why not go serverless tech instead of Spring Cloud? Serverless has its can actually run inside a microservice, and serverless really is event driven. So where you saw there, I have an application that's running, and it's connecting to all of these different registry services and using managed services, and it can connect to an event. But event, in the background of an event, it's really running Kubernetes. So what we don't tell you at Microsoft is when we run Azure Functions, we're running and we're spinning up micro containers there that are running on a custom Kubernetes cluster. So when you run a function, you're actually running a clustered container instance. But we take a lot of those needs to understand Kubernetes also away from you. But the focus on serverless is event driven. All of our customers are really using it for event driven. You get an email in, you get a file in, it triggers an event, it performs an action, it dies. It's not really meant to run continuous enterprise systems. And that's really the difference.
Awesome. So
how to monitor your health? Yes, let me give you a demo of your K8 cluster. So once I've got this here, and I didn't actually have time to do that. So I've got my distributed tracing. So you can see my screen here. I click on distributed tracing. And remember we did Sleuth and the Zipkin, and I can go view application map. And I've got my application map in my last hour, and we had a few services there. I'm going to go a little bit more in the last 24 hours. You can see there, it's going to give me that, and it gives you the distributed tracing. Let's make that a little bit bigger. With the instance, the gateway to my actual to-do service, my user service, and it also gives me that we had an error. I can click on that error. I can go into my logs there, can investigate my failures and see what my failures are. I can see there was a 400 and 404, probably with the Kubernetes issues. I can go and click on that and drill into that and get the actual request that the client gave for why the error happened. And this really now, if I had this with my Kubernetes cluster, I could actually go in and debug why the problem occurred, look at the telemetry, look at the speed improvements, and make changes. And this is the Azure Spring Cloud Starter Sleuth and Zipkin that you want really to debug your Kubernetes clusters. Thank you so much for Vivek for asking that question.
Awesome. So that's all, Rory.
Thank you so much for the time today. And as before, I'm going to put the slides one more time there. Get started with Azure Spring Cloud starters, and then the workshop. And I look forward to seeing you on my Twitter profile at Rory Preddy, and also at the conferences that we're going to do. Thank you so much for your time today.
Thanks a lot, Rory, for joining us today. And we'll definitely share all these links with our participants so that they can go through it. So we hope to have you again in some of our future conferences. Thanks a lot, Rory.
I've had a great time. Thank you.
Thank you. Okay, so guys, that was Rory from Microsoft. So with this, we are done with all our forenoon sessions. Now we'll be heading for the lunch break. After lunch break, we'll be having the quiz time. So let me show it to you, the agenda for forenoon sessions, afternoon sessions. So if you could see, like in the afternoon session, we'll be joining back by 1:30 p.m. IST, and we'll have the game time. After game time, we'll be starting off with our first afternoon session by Arvind. Then we'll have Soumyadip from Hoichoi. Then we'll have Haimantika from KonfHub. And at last, we'll have Arpita from Microsoft Learn Student Ambassador. And after Arpita's session, we'll be having the closing remarks and the winner announcement for quiz and referral contest. So guys, as I mentioned, after the lunch break, we'll be starting with game time. So please don't miss out. Come back soon. We'll be starting off with the game time by 1:30 p.m. sharp. Also, let me show you the learning resources again. So we have a nice set of jCloud contents for Java and cloud developers. So here's the link. You can go through it and you can find all the documentation for Java developers. So guys, you can go through it. Also, we have a really exciting challenge happening. It's called Azure Dev Challenge. You can participate in this challenge and earn a Azure Hero badge. So what you need to do is you need to complete one of the Microsoft Learning paths from this link, and then share the MS Learn profile and the achievement badge using hashtag jCloudDay on Twitter. Afterwards, you need to subscribe to the Microsoft.source newsletter. So what it is the digest of all the upcoming relevant technical events happening, and you can find all the technical contents here. So guys, would request you to go through these learning resources, the Azure Dev Challenge and the Microsoft.source newsletter, so that you can get benefited out of it. Also, the conference is being sponsored by Microsoft Azure, and we have a lot of community partners who are supporting us for the conferences. So we are really thankful to them. So guys, with this, we'll head over to the lunch break, and we'll come shortly by 1:30 p.m. IST. Hello everyone. Welcome back to jCloud for the afternoon sessions. We hope that you like the forenoon sessions by Srinivasa, Sandra and Rory. So, so as we mentioned before that now we are going to have the game time. So it's the fun part for the conference. So let me show you how it's going to be. Okay. So we have the quiz and these are the rules. So what you exactly have to do is will be sharing the quiz link. We'll have the questions and the will stop accepting the responses by 1:40 p.m. and the top 3 winners will get rupees 500 cash each. The game rules are there will be 10 multiple questions. The top scorers will be selected for the lucky draw and the lucky draw winners will be announced towards the end of the day. So without wasting further time, so here we go. Here's the link. I'll share this link in the comment box. So guys, hope you all have received the quiz link. So it's there in the comment box. All you need to do is go through the form, answer as many questions you can because the top scorers will be selected for the lucky draw and out of that lucky draw, the top 3 winners will be selected. So guys, will stop accepting the responses by 1:40 p.m. So hurry up. So guys, we are soon going to stop accepting the responses for the quiz. So requesting you all to submit the questions as soon as possible. And the winner taking process will be the top scorers will be taken for the contest, and we'll be doing a randomization, and out of that lucky draw, the top 3 winners will be taken. So I hope all of you have filled the quiz form. So see you soon after the conference. We'll be announcing the winners by 3:40 p.m. So we have next Arvind with us. So I'll put him on the screen. Hey Arvind. Sorry Arvind, I'm not able to hear you.
Okay. How are you? All good?
I'm doing good. How you do?
Yeah, I'm good.
Yeah, so thanks a lot, Arvind, for joining us. So we had you for CC days as well. So,
Yes.
and people really liked your session.
Definitely.
So in the forenoon session, Arvind, we had Srinivasa, Rory, and Sandra. So we are going to start off with the afternoon sessions with you, and you
Sure.
are the first speaker for the afternoon session. So I would request you to give a quick intro about yourself, what you're doing, and what your session is going to be today.
The session is about kind of, doing distributed tracing for Java applications. So it is more in terms of, like how do you trace your Java application? How do you find your errors, bugs, and response timelines if you are implementing a microservice, if you are implementing a small app or a large app with a lot of things. It's I wouldn't call it as monitoring, but it's more of understanding what's happening in production in cloud environments about your Java application. So that is what is about my today's talk. It's very crisp, and also like it has a bit of demo. So I'll see if I could complete it. If not, I think the code is available online, and also the slides are up on the online, so that you could also follow me along that. Yeah.
Yes, yes. We'll definitely share across the slides and the contents, and people definitely go through it.
Definitely.
So, Arvind, shall I put your screen on screen?
Definitely. Let us get it started. And I think I have already shared, and then we can start a bit
Yes.
faster.
Yeah, Arvind, so you're good to go.
Great. So thank you for joining, everyone, and thanks KonfHub and the team for giving me this opportunity to present this talk today. And this won't be really so heavy. I don't want to burn you down and push a lot of content on you, but I want to just definitely give you a good idea on the technology and give you a brief demo. And we'll see if we could look at more things. So specifically, before starting the presentation, I would definitely like to start with creating the cluster, so that we would save time when we come back here. We would definitely have some a head start in terms of things. Okay, so this is taking time. Great. So I already have a cluster, but what I'll do is like I'll create one more cluster just in case, and then I type jCloud Azure, and then I'll create Singapore, and then the latest stack, and then I optimize, because this is the template which will give you everything, and it also has a bit of like the APM that we are specifically talking about. I'm not going to deep into the internals of how you create this thing. What we are creating, I'll also tell you about that, but just in time, so that by the time it takes 2 or 3 minutes, rather than waiting for that, you could just simply go off and start. So about the session, I did mention about it, like say what is tracing Java applications, Elastic APM, buzzwords or like, different stuff. We're gonna go through it and like see more about it. So first of all, I'm Arvind and I work at Elastic as a developer advocate. I kind of like take part in the open source projects, and then a lot of things around in and around the cloud, Kubernetes, and then many other projects. Quite happy to present at this conference. If you have any questions or things, you could always refer to my blog about the presentations. It's in the talks section, or also you could also DM me if you have any questions. I would drive you towards this particular area. So the key takeaways of the session: how do you trace your Java applications? Simple, clear, easy way. How do you go and look at that? But basically, before understanding that, I would also want to explain you about the whole and soul, the Elastic Stack. People call it with different names, called ELK, etc. But it is called as Elastic Stack because the reason that Elasticsearch, it's the heart and soul of this entire thing. And then you have it's a search engine, it's a distributed NoSQL data store. Then you have Kibana, which is like a visualizer. We'll see Kibana about Kibana today. And then you also have Logstash and Beats, which are the ingestion modules which will pull data into the Elasticsearch. So that is the thing. So there are a bunch of solutions, use cases that you could use Elasticsearch for, or this entire stack. So one being, observability, very popular. People use it for logs, metrics, traces, etc. And then you also have search and security. Security is like the real malware, antivirus capabilities, or SIEM and EDR capabilities. So these are the solutions. We are going to target a thin slice in this particular solution, observability today, that is tracing. So, and then like the stack is used by quite a few people. If I have to tell you that who uses this stack and what is the use case, you might have heard about Elk or Elastic Stack, but like who uses this? What is the use case? Used by developers, like people who build search engines for popular e-commerce companies in India. Like almost every search engine that you probably interact. I'm not talking about Google, that's a B2C, but like if you talk about B2B search engines, like suppose if you're talking about e-commerce site and like ebay.com, at several experiences that you see search bar, and developers who build on top of Elasticsearch to create a search experience, not just front-end, back-end engineers, a lot of people, full stack engineers actually. Then you see also DevOps professionals, practitioners who build these operational experiences, dashboards, etc. And then you also have people who are in the security world who does SecOps, NOC, SOC, SOAR, or like InfoSec professionals. The entire InfoSec community, they also use it for security, threat hunting, security incident analysis, anomaly detection, a lot of things. Excuse me. And then you also have people who are from the BI community, business intelligence community, or people who have varied other use cases with data science, etc. They also use it as a data store to accelerate it and fast forward to find out results in a faster manner, in a relevant manner. So these are some use cases or some people who use it. You might be one of them as well. So that is one another thing to look at. So I'm going to talk about more things. I'm going to also look at the questions and answer them so that like we have ample time to do all of that. So deploying Elastic Stack, obviously you could deploy it on any cloud. It's platform agnostic. You could deploy it on any cloud. You could also run it on Kubernetes. It is not Elastic Cloud on Kubernetes is not a cloud itself. It's an operator that we shape so that you could deploy it in an automated and managed fashion on top of Kubernetes. So that is another thing to look at. And all of these clouds, as I showed you, I spinned up a cluster just now on Azure. Similarly, you could also go to Azure, and through Marketplace, you could also like do that same by still using your credits or your free tier whatsoever. It also comes with a free tier, but you could also use it your cloud credits, etc. So now, okay, the holy grail, like what's APM and how it is related to the session, and what are the things that we are talking about, and what is tracing and what is APM. So all of these questions. So APM APM means like application performance monitoring. So if you think about this particular side, like for example, if you are looking at you have a web service in Java which specifically says like get me the top 10 of some specific thing, or the 10th record of from the database, right? And then you are getting a response. Like you want to ask a question, why does Why did my request took 8 seconds or 9 seconds or 10 seconds? Like, or similarly, when you ask for a query to your server and the server failed to give it gave internal server error or gave a null pointer exception, or it gave a blank screen that you don't know, that you or a user or you as a developer don't know. How do you debug this? How do you find out? Obviously, you might tell me that, okay, there are logs, Arvind, there are metrics, there are many other things that you could go and look at it. But let us think it, if given a chance that you being able to know what's happening in the production, where things are failing, or what errors are there, without your quality assurance or without somebody else like a user raising a support ticket, proactively fixing things or proactively finding things, that would be a great thing, right? So APM solves one particular piece in that entire area. I'm not saying that APM is a whole and soul. It has other modules that would help you to do that actually. To better, logs are still important. You have metrics, etc. But then like APM plays a pivotal role. It's a very interesting place. So yeah, like I said, your request response flows, your entire response time percentiles, like how much time that this page takes to load, or how many times it has given 200s, how many times it is giving 500s, or in a specific time period when the demand is more, or when if you're doing something like big billion days or something like it might be giving response time percentage. So in a specific time, how much time it is doing all of this, like that is also another important interesting thing to look at. And then like obviously errors and bugs, we'll see if we could generate an error, or I'll show you from the demo application that if you could generate an error from it. So again, asking the same question, why so important, right? Important because like say if you are a developer and then you're kind of like deploying your application to the cloud, and then as a user who interacts with the application, like consumes this whatsoever your business that you're doing, and then he might be seeing the errors, he might be seeing the warnings, he might be seeing delay in the load of this entire thing. So but when you enable APM in your applications, when you do all of this, it becomes very easy because your application starts speaking from inside, explaining what's happening, and then you'll be able to simply fix the bugs, and then you can have that sort of a similar seamless experience. So this is what the entire workflow as in you could talk about. So it also explains you the convergence of this all three important practices. Like you're a DevOps developer, if you're a developer shipping to the thing, or if you're a SecOps professional, wherein you have the doing this entire security in your cloud. All things go together in cloud, right? It's not just I'm an engineering, I'm a developer person, I just want to put things together. So you need to follow all the best practices. That's where your logs, your metrics, your traces, all of them, these things, like I said previously in a few slides back, where you have this 3 modules or 3 important pieces or pillars that play and let you find out the issue in that area, where you will be able to correlate all these things at a single point of time and help you to establish an observable infrastructure or cloud or application system actually. So in precise, like how the architecture looks like is very simple. You have a Java app however it is running, be it in Azure App Service or Azure Kubernetes Service, or probably in any cloud or Azure VM or any other, not just Azure, any other cloud or in your on-prem data center. When you enable this APM, I'll also tell you how, when I'm enabling this APM, what does it mean that enabling APM means. So I'll also explain or talk about that in the demo. So it streams its data to the APM server, and then like the APM server condenses all of this. This entire thing that we are seeing, we have created just now, like in the previous tab when I started this demo, I spin up a cloud cluster. So this entire thing contains the cluster which we are spinning up and which we try to connect through our application and try to get some details actually. So this is how the overall architecture looks like. It's pretty simple. You just need to run your app, and then like it automatically picks up and starts tracing actually. Now, another interesting thing with Elastic APM is it's completely open source, Apache 2.0. You could contribute to it, learn from it, look at the code. So all the APM server, the UI, the agent, all the types of agents. Again, it's not just one language, right? There are multiple languages as well. Now in the microservice world, you have different languages suitable for each and everything, communicating with each other to do more interesting stuff, right? So you could also go and look into that as well. So you have all these reports you could always contribute. The GitHub location is like elastic/APM. You could go and look at that actually. Now, talking about the Java agent specifically, it is powered by a code instrumentation library called ByteBuddy. We are also like officially like we also help sponsor the developer who runs this ByteBuddy. The library, a jar which helps you to do all of this code instrumentation through Open Collective, an initiative to fund open source projects. Then you also have different modes to how to enable attach to this Java process. So in Java, it is run, all the Java applications run on JVM, right? So through some instrumentation techniques, we would be able to connect to either through a Java agent flag or through different sort of attachment techniques. I'm going to show a very simple one that if you could make one line code change, it will all seamlessly support your thing. It also supports all the major web frameworks, data stores like MongoDB, so that you could trace what's happening, how much time the query took, right? MySQL, PostgreSQL, you'll also be able to see that. You'll also be able to look at, the Kafka modules, like your message queues stuff when you're pushing through your Java application to this thing, and how much time it got when you procured it from that particular message queue, or even app servers like your WebLogic or WebSphere or Tomcat or JBoss, whatsoever web server you are running. It also supports and gets important metrics or data that pulls up and shows you in your traces actually, and it's all correlated, it's all tied up so that you can easily leverage all of that. Now that's not it, there's more. So we'll quickly see a demo, and then I hope that the particular this thing is ready. So I just want to download this one and then see if I could open the Kibana here. So quickly we'll take a ride through Kibana, and then like we'll quickly like kind of see the entire application actually. So for the application, I'm using a specific technology, web framework technology, which is a lightweight control. It's called Javelin. I'll come to that quickly. So as you see that, it shows that observability add APM. You could click on that, and then you could simply show different applications. Now we are talking about Java. You just need to add that Maven from the Maven Central, that dependency. If you're using Maven, we also support other Gradle. Or if you want to just download the app, yes, go ahead. Even you could go to the code and like download from the releases. You could also go download a release candidate as well, the future beta, compile the code and do all of that. So all of that is possible. So there's a Java agent flag which is explained here. So what I'll show you is like I'll quickly go through this thing. Like there are multiple areas, but we are going through APM here. So I don't have anything set up. It's all empty right now. Let us see if we could, set up that thing. So the framework that I'm using here today is like the Javelin. So which is a very simple web framework written in Kotlin for Java and Kotlin for both languages. And then it's very interesting, and then easier for me to demonstrate quick demos. I also want to give some caveats. I didn't enable HTTPS. I didn't have a the authentication base, etc. I didn't do all of that, but I intend to do. And then I just don't want to complicate everything. I took a very small create, read, update, delete application. And how Javelin works is pretty simple. It takes a Jetty as a base. Jetty is a very popular lightweight server, and it writes a smaller framework so that you don't need to implement any interfaces or classes, etc. You just need to simply be able to create APIs, just like your Flask, which is again a popular Python-based application framework that you could do all of this very easily. So yeah, it shows all of this, and then like you could learn more about at the Javelin site, again open source project. So I have my code already shipped here. I think in the comments you will be finding this. Otherwise, I'll give you the link at the end. I also have the Azure thing set up, so that I will push my code to this particular place, and then like I'll try to deploy it to the app service. Now we have very less time. I'll quickly go back to the code. So the code that I have here is like this one. So I have few dependencies. This is my Java Lin, the project. So let me show it to you here. So I have this dependencies like you see here. Java Lin dependency, then I have SL4J, which is for logging, and then I have APM, the dependency thing that I said like I'll download from the Maven Central, and then the Jackson binding for some specific use. Now, what does the code look like? It's simple. I have very few things here. I know this might not be very visible, so I'll just open the site here. So like I said, I have a simple main JS application. And then I also Dockerize this so that when we build this thing, when the jar comes out, I can be able to build a Docker container and push it to the cloud, and then we could build all of that. So I'll quickly show a small demo of this application, and then we will do the cloud proceedings. Actually, it's already running. I'll stop and rerun. So I'm using the JetBrains IntelliJ IDE for that. But then you could also use Visual Studio. Somehow, for some reason, my Java extension isn't working. And then I don't want to take chances, and I'm just using that. So here I'm using the Postman. So Postman is kind of a client for running all of this. So what happened here, I'll explain you here. What happened is like we are running a student create update delete program. I mean, wherein it takes the student details through JSON into a map. And then if you see here, we are starting a endpoint on students on localhost 8080. Now let me see if we could access first of all localhost. Localhost 8080 not found. Great, it says, because it is not on that particular place. It is here and it shows empty. So if you see here, it shows an empty, the thing, the map here. So we have a student controller. Again, this code is very custom to Javelin and it's very easy to set up. So if you want to do a create, read, update, delete database control, you just need to implement this CRUD handler, and there are methods, and then you can do create, read, update, delete. Very simply, I use the map, make it very simple, not to complicate more with other DBs, their connections, etc. So I'm not doing all of that. See, when we did get connection, it calls like all the get all method. So similarly when you do get one with the ID, resource ID, it will bring up that particular thing. Similarly, all of this is again there on the GitHub. You could also go and look at that. Now without any delay, what I'll do is like I'm using Postman because through which you could do this API calls, etc. There are also other tools. I'm just using Postman here. So I have this students. And then if I say get, right, so it just ignores the body that is there here. It says me empty. But what I'll do is like what I've done is like I've chosen the body and I have raw and I've selected JSON. Remember that I didn't have any authorization header. That means like if this is on cloud and everywhere, everyone could access. So what I have is like I have created a small sample thing here, and then I'll post it to the API. So we'll see whether it gives you a result. Okay, it worked, and then it has published. Now let us see if we could do some more. I don't know Rohit's age, but I'm assuming it's 23. I'm just guessing. So sorry, Rohit, I just took a guess. Then you also have tree, and then we're just putting more and more names, and then like you have all of this, right? Then you do a get. Ideally it should return everything, so it returns all of that. So if you see, it returns all three. Then status and everything. If you do so this is what our application does. If you do 001, it should return 1, 2, it will do that, and then like 3, yes, and then you could also patch it. I'm not showing that, and delete it, which we'll try on the cloud thing if we can deploy by the end of this session. So this is how the application works. This is what is happening here. You could also see the between these errors that are being popped up. I'll come to that very quickly. You also see that get all students, get student 1, the logs, etc. So what is this error and how we can fix this? So specifically what's happening here is the APM is trying to connect to the Elastic Stack or the APM server and to push all the details that we need here so that you could have that view actually. So we are not doing that. We will do now. So what I added here is in the main class, I have this APM attacher, which attaches this entire main process, and then like it will start the calls can be intercepted. Now you could also go and put an annotation. We also have an annotation through which you will be able to do only one specific code block, right? You could also do that as well. So that is one another thing to look at. So you would also be able to, be able to do all of this pretty easily. Now let me come back and then add that. So I have this APM attacher library. I also have this imported because we have in the dependencies. And the another thing is like where it would connect, right? You just can't, put everything and like say, just connect. It needs to give the server URL. So what happens here is you need to give the APM server URL, which we already have because we have deployed here. I'm saying copy endpoint and then pasting it here. Then I also have the secret token, which is a token specifically for the APM server because you can't accept anything and everything. So I have the secret token here. I'll just paste it there and then I'll say save. And then what we'll do is like we can check it here. I have named the server as Javelin. So let us see if there is nothing here. Refresh, nothing. I don't have anything. Let me kickstart this thing again. And we'll see once whether our application is pushing, and then we'll push to cloud. We'll see that at least completes one cycle of the demo, and then we'll be able to look at things. So I'll not say last 15 minutes, at least last 5 minutes. And I'll also say last 1 second and refresh it every time. So I know it might be very small, but I'll just try to increase it as we go. So I'll just quickly want to give a nudge to this so that the basic thing would be created in a minute when the data is being sent. We'll also keep doing the same stuff because we restarted, the map might lose its memory. So let us quickly go and see everything. Students, it's empty. I'm doing a get. I'll do a post now. And what I'll do is I'll just insert the same thing, right? Okay.
I think, sorry to interrupt you. If you want, you can go slow. We have pretty much time.
Okay, great. So I'll quickly keep doing the thing. I'll continue. So I have Rohit, and then I'll add one more thing, and then we have KonfHub, which is like Suite 16, right? So we'll add that as well. I think I have updated the same thing, but let me also add. So get, we'll see what we'll get. So I have 3 items here. And now we did some operations, like we called the API and we did some sort of, do all of this. So let me go and see whether this has come in or not. I'm not doing any sorcery here, but it simply came in. And then it also shows average response time, transactions per minute, and then errors. There are 0 errors. Okay, great. So we'll also see, okay, let me put it this way. So we'll also see that initial spikes because we are the ones who are sending the request here. Time spent, I'm selecting the request specifically. And then you also have the error rate, time spent by each span. Most importantly, we did get and post. We didn't do put, and we didn't do patch, or we didn't do the delete request. We can also do that. So most of it are gets. And then we also have, because it's a single span, it tells that what are the other details that happened. So this looks very simple and easy. Actually it is the same way, but I also want to tell you that when you are doing a complex microservice application, even there you would feel that you'll feel that you can construct all of this from there. Here, if you see, you could also look at the host logs, host metrics, that particular host, and the trace logs. That means whenever this request happened, whenever this error happened, you could go to that logs. How interesting it is. We don't have enough time to showcase the log side of things today. I'll show you another demo application, but then that is quite cool, right? So you'll be able to debug everything. You'll be able to trace and understand what's happening. You also see that there is one request which took more time. Just this is a swim lane, and then I have one request which took more time. I want to see which request is taking so much time. Why? What's the reason? Perhaps some reason that in my code, something wrong. What is that code? So you could do all of that pretty easily. And it's quite amazing to, go and look at all of that. Now, what we'll do is we'll quickly come back. We'll quickly, what we'll do is we will also deploy this code onto the cloud and then still keep monitoring the same stuff again from here. So I'm using again shifting gears from here from IntelliJ. You would also be able to push all of this from IntelliJ. You have Docker for Mac, extension that you could add as a registry and then push this from here. I am running a Docker for Mac thing, but then I chose Visual Studio because the ecosystem is quite good there. So what I'll do is like I'll delete the earlier repository so that we can push it freshly. So I have installed the Docker extension here. I also have Azure App Service. Once we push the data, and then you'll be able to simply do all of this pretty easily. So let me quickly. This is same code. Nothing has been changed. I'm just going to give few commands and build this container. Like say build this image. Say Java student, and then it goes through few steps. It's very lightweight. It is few MB. That way Javelin is also very popular and the capable. So now it is built. I'm just going to push this to a container registry. So the place where we could simply like access the images and push the image to the cloud. So where should I check this thing? So you could go to the Microsoft like the Azure, and then you have container registries. Open that, and then you have this particular repository which is dev-dish.acr.io. Similarly, you have other container registries as well. So container registry is very, very popular. Like you could store your containers just like Docker Hub, which is a public Docker containers wherein people store their containers. If you do Docker pull so and so. Similarly, you could also do Docker pull dev-dish.acr.io/javelin. I'll show you in a minute. So you could do all of that. So I have created a repository there just in before time. It's called dev-dish. So that registry I have created, and then I push this image. So if you see the image has been pushed here, it says that the image is done. I'll go and click into this thing, and then it shows latest. From here, you could deploy into multiple services, to tag them, run in container instance, deploy to web app. You could do all of that. I chose to do things via my IDE, quite comfortable that way. So I just want to refresh here, and I'll also minimize this so that you get a clear view of what I'm doing. Yes. Okay. So you see that I have this particular thing, and then I don't know why it is showing this way today, but then this is quite useful if you do this. So okay, so you have this the same latest here, and then you could there are so I think this is quite visible. So there are these right click menu items, like you could pull image digest, and untag image. Like I said, if you go detailed into that, you will see that, right? I have this Docker pull dev-dish.so and so, and then you would also be able to push this, bring this container. And then it's like hosting your own container. What I choose to do is like deploy my own image at Azure App Service. So I'm just trying to create a website out of it so that you all can access. So I'll want to give this name as Javelin, just for the name of this particular, or let us do jCloud. That's good. It might take a while, but then we'll see if you could. Oh, jCloud exists. Okay, Javelin. I don't know. So maybe it's me who did this. It says create new app service plan. Yes. Name of the app service plan, free, and then select new resources. I choose Southeast Asia because it's probably near, and then like I'm trying to do that. So I'm not sure whether there is an existing thing, but let me check. If there is an existing website, we could simply go while this is getting deployed. So let me check. No, there is no existing website. So we need to wait. So while this is happening, I'll show you the links. Once this comes up, you can open your own Postman, and then you kind of like be able to create this, call this API service, and then generate the data, and we could see the data in the APM service as well. So it says successfully created. You could also go to javelin.azurewebsites.in. I click open website, says yes, open websites, and then it takes a while because it's loading for the first time on public internet, so it needs to figure out some stuff, and then it connects me to my site, and then my web service is also up. So we have created a full-fledged circle through this thing. Now let me show you, while this is loading up, let me show you the other stuff. Now if you want to access the resources, how I created the thing, or you want to comment on or ask questions like in future, not just now, I'm anyway here, but then you could use the link here that is shown, ela.st/java-apm. Then there is community.elastic.co. You could also register there for all the future updates like these talks, etc. There is a Slack group that you could also go. I'll ping onto the YouTube link, and then you'll also be able to join the Slack group for asking more questions. So I hope this is ready. I hope this is showing application error. That's great. Let me go and say students. Okay, something wrong. So what we'll do is the ideally it should come up. I am not sure why it is not coming up. Let me see if the old website is still there. I don't think even that is there. So yeah, this web app has been stopped. I don't know what's the reason, but then what happens is you could simply able to deploy this entire thing and then run this from your cloud itself. So that's it from my talk. If you have any questions, I think I've seen some questions. Happy to take them now. Any questions?
Awesome, Arvind. That was a really nice session, and
yeah,
I think you had to run very fast.
I have multiple things to do, so that's the reason that I haven't shown a lot of things. I have a full-fledged microservice app as well, but it is difficult to do it in simple terms. But then it's quite useful, right? I mean, as a developer, probably you could understand. So these are the errors and exceptions. If you get in an app, you'll be able to kind of see them and go through them. Yeah, we'll
Awesome.
take quickly some questions. Yeah.
Sure. Arvind. I'm just showing the questions.
Great.
So there's first question.
Okay, Madhu, I think Logstash is heavyweight. So one thing I want to tell you is Logstash is like ETL. You could use Logstash, or we have new technology now. I think Elastic Agent to push all the data from your anywhere to push this place. APM is another line completely. So Logstash still continues to be there. Under right configuration, it will perform. Many people use it. But then you could use Beats. Beats is another, agent, or Elastic Agent or Beats are more or less same. You'll be able to push data of your choice related to this particular thing. So that's how you could work with. Many people use Beats as a daemon set in the microservice architecture in Kubernetes or OpenShift. Push the data.
Awesome. So I'll take one more question. So
sure.
So is the same question from Madhusudan?
Yeah. So there is one more question from Madhu saying okay, Elastic Cloud is like a cloud service like Azure. So we run it on top of a cloud. You get a free trial to get started with the cloud, and it can also be you can talk to us and then let us know what your use case is, and then we could help you to build on top of the service actually. So it's just like any other cloud platform. It's not but it runs the open source technology with all the bits that you need, like the security, machine learning, and everything. So it's Elasticsearch as a service plus a bunch of other solutions that we offer to the customers.
Awesome. So I think, Arvind, that's all. Great. So we'll also share your slide and the learning resources which you have shared with us.
Yes.
So that participants can go through it and use them. And thanks a lot, Arvind, for joining us today and again, sharing your experiences and contributing to the community. Thanks a lot.
Thank you, Rohit, and the KonfHub team. It's been a pleasure, talking at jCloud. Thank you.
Awesome. Hope to see you soon in future. Awesome. Thanks. Bye. So, guys, that was Arvind from Elastic. Since we are running a bit short of time, so I'll introduce Soumyadip, who is the next speaker. Hey, Soumyadip. Hello, Soumyadip.
Yeah, hi. Am I audible? Am I audible?
Yeah, you're audible. Yes, but I think there is some network issue from your side, I think.
Yeah, a bit. Yeah. So now it's audible.
Yeah, it's audible. It's audible. How are you doing, Soumyadip?
Yeah. So I'm doing good. So what about you?
I'm doing good. So, Soumyadip, before you, we had Arvind from Elastic, and
Yeah.
we're really glad to have you as a speaker for jCloud. So,
Yeah.
so would you like to give
Yeah.
a
Thanks.
quick intro about? Would you like to give a quick intro about yourself and what your talk is going to be today?
Yeah, so basically, I'm currently working for Hoichoi Technologies Private Limited. That's the OTT platform of our West Bengal. So it's the largest OTT platform of East India. So currently, I'll be talking about that. What are the like components of Java microservices and how we can deploy all those microservices in Azure. So what are the like facilities we have in Azure? Like in Java, we have Eureka. In Azure, we have the same thing for the deployment and all those software load balancing. So I'll be talking about that today.
Awesome. So, Soumyadip, shall I put your screen on the screen?
Yeah. Yeah.
Awesome.
Thanks.
Here you go, Soumyadip.
And now it's visible.
Yes, it's visible.
Yeah. So let me go through all the slides. Then we'll take questions. Okay. Yeah. Is it visible? No?
Yes, Soumyadip, it's visible.
So basically, now we'll be talking about that. What is Java and like what are the microservices that we can use in Java, right? Now, so now Arvind just told that there are many microservices that we can use, we can build, and we can deploy, right? But there are some things that we like every time we go for the microservice, every time we'll build all those microservices, we have to manage all those things, right? Now, how to manage that? So nowadays we have so many components like we have Netflix Eureka, we have Netflix Zool, we have Hystrix and Zipkin. So these are the main components that using this you can trace your microservices, you can trace the logs, you can trace that how your microservices is going, what is the load time and all, and GraphQL and Kafka for message booking. So now in my session I'll go for the Netflix Eureka and Zipkin. Yeah, now let me talk about let me tell you about the discovery things. So what are the discovery things? So Arvind has just told that how to create a microservices and how to deploy that microservices in Docker and how you can push all those microservices as a live API, right? But what about when there are around 100 or 200 of microservices? Suppose let me talk about the Flipkart, right? Flipkart is completely, or Amazon, that is completely microservices based, right? Now, how to manage all those things? Now we have a support of Eureka and Zool. So using Eureka and Zool, you can manage all your microservices. Now, for let me talk about the load balancing. So when I'm talking about the load balancing, there is two types. One is your software load balancing, and another one is your hardware load balancing. So as we know that hardware load balancing is very costly, so it will take so much maintenance and so much cost, bandwidth and all. So let's go for the software load balancing. So every time for the minimum cost, we have to go for the software load balancing. But your hardware load balancing can be done by your like what who are the operational guys and all. But what about the software load balancing? So in software load balancing, we have a support of Netflix, Eureka, and Zool. This is basically a like discovery services. So using this, you can monitor all of your API and you can like shift all of your API. So let me talk about the Netflix Eureka. Now, Eureka is a REST service based on the primarily used in AWS cloud. So Netflix we basically use for AWS clouds. We have a like alternate in Azure. I'll talk about that. Now let's at first talk about the Netflix Eureka. So now as we know that Netflix has a like huge amount of traffic, right? So let's see this. So let me talk about the load balancer. So when there is a request, so it will go to the load balancer and there are hundreds of API. So what Netflix like what Eureka does, Eureka will shift or divide all of your requests and it will like create all those balancing stuff by your own. So you don't have to worry about everything. So you can see that this is the instance, say the request is going to load balancer, then the request will go to service registry. So you can see that from the load balancer, one request is going to query going to the service registry, that is your Eureka server, and another one is going to the REST API. So it will hit the API and it will fetch the request, then the client will get the response. Now, so how it's working? So see, now suppose this is your REST API and suppose you have two ports, one is 8086 and another one is 8085. Now you have two Eureka clients. So in Eureka we have two things, one is Eureka server and another one is Eureka client. So you have to deploy, and in your Java code, in your Java, like in your Spring Boot application, you have to like add the dependency of the Eureka server. You have to create a separate Eureka server for that, and all the things, all the APIs, all the clients will be monitored in your Eureka server. So let me show you that. So this is your Eureka server, and this is the current register that you have. Suppose you have a like huge you have separate microservices, like you can say that A service, admin dashboard, authentication service, B service, gateway. So these are the 5 microservices that we have in different instances. So you can you can maintain all of the microservices, and or you can manage all of the microservices in one go, right? So Eureka is built like whatever microservices you will build, you can manage all of them. Now, so just a minute. Yeah. So see, suppose you have a gateway. So your this gateway will be connected to the Netflix Eureka server, and which is basically Spring Cloud. And suppose you are passing four like you are calling 4 microservices, so it will go to like respective microservices, and all those stuffs will be balanced by your Eureka. Now, so what are the things that alternate we have in Azure? So in Azure has also a discovery service that is called Azure Container Service. So that is basically a alternate of Eureka service. If you are going for a Azure Container Service, then you can go to that. I'll give you the link in the description. So Eureka has as we all know that Eureka is the open source tool, and it has around 7.9K, and it's a very popular framework. And now what about the Git? See. Yeah, so I'll send you the link in the description. So this is all about Eureka. So you can visit spin.io, then you will find all those stuff. Now let me talk about the Zipkin. So anyone has any idea about Zipkin? So what Zipkin is? Zipkin is a very powerful monitoring tool. Now till now we have talked about the service registry tool, that how we can manage, how we can balance all the softwares. Now we'll talk about that. After managing, you have to get the details that how many times it's taking to discover all those API, right? So we'll talk about Zipkin. So Zipkin, suppose if you are working on microservices, you all know that what Zipkin is, what Cloud Salute is. So let me talk about that. Now, decoupling in cloud era, building cloud native microservices with Spring Cloud Azure. Now, what are the key points? Cloud native applications should exploit full advantage of cloud. Now, let me go through this. Okay, so this is your API gateway, and in your API gateway there are multiple factors, like there will be multiple microservices. Now, how to trace the logs? There are many logs, right? So you can trace all those distributed logs using Zipkin. So see, so this is basically your Zipkin dashboard. So based on this dashboard, suppose you have around in Amazon they have around thousands of microservices. So in Zipkin you can monitor all of them in real time. So you can explore Zipkin. I'm giving you the link in the chat section. So let me give you the link in the chat section. So you can go to Zipkin, you can explore all of them. Now, how to deploy this Zipkin? So Zipkin is basically a separate jar file, right? So you cannot directly integrate. Suppose you are building a Spring Boot application, you cannot directly deploy that. So for that, what you have to do, because your Zipkin runs on a different port, right? So now what you have to do for that, you into a different container. Based on that, you can monitor your service. And suppose you have around 50 or 60 microservices call, and suppose there is a microservice chaining, you are calling 1 to 2 or 3 to 4, everything will be monitored using Zipkin. Now how to deploy this Zipkin, or how to connect your Zipkin with your native Eureka client or Eureka server or your Spring Boot application. So let me tell you about that. So this is the distributed tracing about how we can deploy your Cloud Salute Zipkin in your Azure. So Microsoft in the Microsoft portal, they have this, you can go to this link, that Microsoft Spring Cloud Azure. So in that link you will find that this is basically open source project. So you will find everything. So you have to deploy your Zipkin separately in your microservice, then it all will these things will be done. yeah, so that is all about your Zipkin and Eureka. So now I think we should go for the questions. So if you have any question, just write in the chat section. So I'm giving some link in the chat section. So Rohit, yeah, yeah, that is all. Is there any questions? Q&A out.
Yes, Soumyadip, let me check if there are any questions.
Yeah.
So as of now, there are any questions. So guys, please post the questions in the comment box so that Soumyadip can go through it and answer your questions.
Like any questions related to microservices. Yeah.
Sure. And also, Soumyadip, it would be great if you could share your contact so that the people could.
Yeah. Sure. I'm sending my contact. So I am sending my GitHub and my LinkedIn profile. So you can connect me on GitHub or LinkedIn. Yeah. So
Awesome.
you can go to that and Twitter also.
Awesome.
Yeah.
Please share
So
that with
just
us. Awesome.
yeah. Just go to this link. I'll try to reply as soon as possible, or you can join me in the Slack group. Yeah.
Sure. So that was a really great session, Soumyadip. Thanks a lot
Yeah.
for
Thanks,
joining
Rohit.
us in
Yeah.
such a short notice and sharing your knowledge with the audience.
Yeah.
So we hope you'd collaborate in future conferences as well.
Yeah.
Thanks a
Sure.
lot.
Like this is very cool. Yeah. Yeah. Hope we
Awesome.
can join in
So
future. Yeah.
I think
Bye.
there is one question, if you would like to take it.
Yeah. Please. Yeah.
So there is a question related to managing caching.
Mm-hmm.
So can you see the question screen?
No cache. Yeah. So if you are trying to manage the Redis cache, suppose, so when you are like, there will be a redundancy. Suppose you are trying to manage a, like, there are like very like 100 of microservices and all are operating on a same cache, like it can be a mem cache or Redis. Then what you have to do, you have to manage a like edge base. So using based on that edge base, you have to like reduce all those things. Then you can manage all those cache. So for caching that, you have to done that explicitly using edge base or any other things.
Okay, cool. So that will be all,
Yeah.
Soumyadip. Thanks a lot. Thanks a lot for joining us
Yeah.
today.
Thanks, Rohit. Thanks to jCloud. Yeah. So bye everyone. Take care. Bye.
Okay, bye. So guys, that was Soumyadip from Hoichoi. So next we have Haimantika from KonfHub. She'll be giving a lightning talk. Before that, I would like to show you the learning resources once again so that you can go through them. So yeah, hope you guys can see my screen. So here are the learning resources. So as I mentioned earlier, like we have pretty cool learning resources for getting you started with Java and Azure. So there is a documentation which you can go through. So it's called Azure for Java Developer Documentation. So we'll be sharing the link in the comment box. So guys, you can go through this link and make use of it. So the link is com.me/jcloud-content-java. Next, we have a very exciting challenge called Azure Dev Challenge. So let me quickly show you how it is. So all you need to do is take part in the challenge by completing one of the learning path which is shown here. So there are total 4 learning paths. You can complete any one of them. After completing the learning path, all you need to do is share your MS Learn profile and achievement badge with hashtag jCloudDay, which is the official hashtag for jCloud on Twitter. After doing that, you need to subscribe to Microsoft.source newsletter. So what is this Microsoft.source newsletter? It is nothing but it is a very cool digest of learning resources, technical contents, and the nearby events and trainings, meetups, conferences happening nearby. So you should definitely register or subscribe for this newsletter. So after you complete this challenge and do the procedures, then you'll be receiving an Azure Hero badge via Twitter DMs. So guys, I would request you to open your Twitter DMs so that we can reach out to you and share the Azure Hero badge with you. So guys, that's all. Next, I'll introduce you to Haimantika. Hey Haimantika. Sorry Haimantika, I'm not able to hear you. Just a second. Not really, Haimantika. Is there any problem with your microphone? No. Is your can you check if it is on mute or not?
Oh yeah,
Yeah.
sorry, I was on mute.
Yeah, no problem. So how are you doing, Haimantika?
I'm doing great, and thank you for the introduction. So today I'll quickly start by sharing my screen, and before that, there's a disclaimer that I am a very beginner in Java, and I have prepared this talk using Microsoft Learning Docs, and I think that if I can do, everyone who's there as participants and viewers, they can do it too. So let's get started. Please let me know when you can see my screen.
Sure. Haimantika, your screen is live.
Okay, so hi everyone. I am Haimantika Mitra. I am from Siliguri, India. I work in my KonfHub technologies, and I'm also a Microsoft Learn Student Ambassador. So today we'll have a talk on how to build a Java web application using Azure Cosmos DB and the SQL API. So let's take a preview of what we will be building. So what you can see is a snippet of the task manager application that we will be building using Azure SQL and that is Java. So now this is basically what we will be creating, and let's get ahead to see what are the prerequisites that we will be needing. As you have gone through all of the sessions before, so an Azure subscription is a must. You can go ahead and have a free subscription if you don't have it already. Then, as we know, a Java development kit, then Eclipse as the IDE, and it's advisable to have an Azure website with Java runtime environment, that is Tomcat or Jetty enabled. So now that we have the prerequisites and we also have a snippet of what we will be building, let's see what are the steps that are involved in building the entire application. Starting with the first and the most important task, that is to create an Azure Cosmos DB account, followed by creating the Java JSP application. Next, we have to install the SQL Java SDK, followed by using the Azure Cosmos DB service in our Java application. Now that we have built all the bits, it's time for us to wire up, and finally we will be deploying it in our Azure website. So let's start by creating an Azure Cosmos DB account. So for that, you will be needing a subscription. So go ahead and get yourself a free subscription. And once you search Azure portal, you will sign in, and you need to go to resource and search Azure Cosmos DB. So now once you go to resource and type that in, a list of results will pop up, and you need to go ahead and click on the first result, that is Azure Cosmos DB, and simply click on create. So the subscription that I am using is a Visual Studio Enterprise subscription. You may have your free trial subscription, so go ahead, it will be automatically pre-populated. The resource group, you can use an existing one or create a new one. I have used an existing one. And now it comes to the account name. It is very important to follow certain criteria while making the account name. It should be unique. it cannot have capital letters, it cannot contain special characters. So once you have done that and come up with a unique name, keep everything as it is, that is pre-populated, and then you can go to review and create. So once it is created, you'll get a notification that it has been created, and then you can get the keys and endpoint that we will be needing in the further steps. So second step, which is to create the Java JSP application. So here are the snippets of how the things will look. First, we will be needing to create a dynamic web project, followed by making a JSP file. In the JSP file, we'll be adding a single line of code, that is println hello world. And the fourth picture that you can see is what will pop up. So let's see how we are creating the dynamic web project and the index.jsp file in Eclipse IDE. So once you have downloaded the Eclipse IDE, it will open up and you need to go to new and project. So the dynamic web project might not come automatically. So you need to go to create a new project, and under web, you will get dynamic web project. So for that, you need to give a unique project name. You can give it anything. For here, I'll be giving it as my hello world. And then we'll see the target runtime and the various filters that are here and keep it as it is. And once it is done, we'll click on finish. Next step, which includes, that is our creating a JSP application, that is index.js file. So here, open perspective depends upon you, so that you can see if there are any errors or no. And once the project explorer pane, it opens in the left hand side, you will get the project names that you have created. My project name is my hello world, so I'll right click on it, and now the next step is to create a JS file. So for that, I'll go to new, I'll scroll down to JSP and then give it a name. So for this particular that is task, we will give it a name, that is index.jsp, and then we'll click on finish. And once it has been finished, it will pop up with the code, and in the body part, we'll be needing to print that is hello world. And once we have saved and run that, this is how it will pop up. So the third step, which includes, that is to install the SQL Java SDK. So this is a pretty easy step, and what we need to do here is basically we need to create whatever we did just now. We need to just convert it to a Maven project, and then we need to populate the group ID box as com.azure, the artifact ID box as Azure -Cosmos, and for version box we need to keep it as 4.0.1/beta.1. So let's again go ahead to our Eclipse IDE and see how it's done. So if you remember, my project name was my hello world. So I'll go to configure by right clicking on it, and then among all the listed options, we'll go to convert to a Maven project. Now when the dialog box pops up, as I had just shown, that we need to populate it with certain criteria or certain text, that is for group ID, it needs to be set to com.azure. For our artifact ID, this again we need to save it as Azure-Cosmos. And then once it is done, we will need to change the version of it. So the version of it, since it already does not exist, so we need to manually type that in as 4.0.1-beta.1. So once we have done this, so this is basically what we have to do. So once we have pre-populated it, we'll just click on finish, and it will be converted to our Maven project. Next, we have how to use the Azure Cosmos DB service in our Java application. So this is where there is some coding involved, but due to time constraint, it is not possible to live code and show, but we have it in our GitHub repository. You can go ahead and click on that. And since this has been taken from a Microsoft Learning Paths, and if you're an absolute beginner, this is a very easy learning path, so you can go ahead and try it on your own. So I'll just brief you through the steps that are there. So first, it includes creating or adding a model. So to add a model, we need to create a to-do item.java file. If you remember, when I showed you the snippet of the application that we have created, there it needs to fill up the to-do items. So for that, we will be needing to create a Java file. and then add the code there. Next, we'll be adding the data access object classes. So for that, again, we'll be needing to create some files, starting with creating the Cosmos client factory.java file. And as we know, it is a good practice to have the class name same as the file name. So we'll also be defining the class same as the that is file name. And next, we have to create another file that is to do DAO. DAO stands for data access object. And basically this file, it will be creating, updating, reading and deleting the to-do items in our application. Next, we will be creating another file that is mock.dao. So basically this is implementing the CRUD operations in the items in the to-do DAO class. And last, in for this particular action, we'll be needing to create a doc.db DAO.java file and then add a class to it. And basically what this does is, it defines the code to process the to-do items into the container, and it retrieves our database. If we don't already have one, we'll go and ahead and create one. So the third and the fourth step is to add a controller and then to create a servlet. Next, now that we have created all the other bits, it is important to wire the rest of the Java app together. So for that, what we need to do is we will need to rewrite the index.js file. If you remember, we had only updated that as hello world, but for this particular web application, we'll be needing to populate with some other code. And once this is done, we'll be finally writing some client-side JavaScript to tie the web user interface and the servlet together. And the last part, that is to deploy a Java applications to Azure website. So now that we have the WAR or WAR file in hand, what we need to do is we need to simply add it to our Azure website's web apps directory. So how do you do that? How do we extract that? So let's go ahead and see it in our Eclipse IDE. So from our Hello World project, we'll right click and go to export to WAR file. And then we need to give the web project a name, that is Azure Document DB Java sample. And then we need to specify a destination. And once that is done, the WAR file will be exported. And once this is done, once we have the file in hand, what we need to do is we simply need to navigate to our site. So that will be http:// your site name .azurewebsites.net/Azure Java sample. So this is how you need to go to your site, and then you need to add the tasks or the to-do items that you will be doing. So this is the brief learning part that I have done as a beginner. I found it quite interesting and easy. So if you are starting with Azure or if you're starting with Java, I think this is a platform that you can go ahead and explore. So I have also given the reference to a document that I have referred to. So that's it from my side, and thanks for having me. If you want, you can drop me a question in Twitter, and that's it. Thank you for having me. Hello, Rohit?
Yeah, that was really cool session, Haimantika. I hope people would have learned how to. Yeah. So, Haimantika, so we have your slide and the learning resources. We'll share it with our participants so that they can go through it. And as you rightly mentioned, like you have also started as a beginner with this thing. So I hope like people can go through it and they can also start off with their own journey.
Definitely.
Awesome.
Thanks
So
for
thanks a lot,
having me.
Haimantika. Thanks a lot, Haimantika, for joining us today. Thank you. So guys, that was Haimantika. Next we have Arpita. So Arpita is a Microsoft Learn Student Ambassador. So before introducing her, I will just quickly show you the learning resources once again and about the Azure Dev Challenge. Okay, so here is the Azure Dev Challenge which we are mentioning. So guys, this is a pretty cool challenge for you guys. all you need to do is go through the Microsoft Learning Path, which is given here. And we have 4 collections. Out of those, you can complete any of it. And after completing, you just need to share the MS Learn profile and the achievement badge using the hashtag jCloudDay on Twitter. And after that, you just need to subscribe to Microsoft.source newsletter. So what is Microsoft.source newsletter? It is basically a monthly digest of all the technical events and conferences happening nearby to you. And you can also get the relevant technical contents, which will help you getting started with cloud. So guys, we would request you to go through this Azure Dev Challenge and earn your Azure Hero badge. The link will be sharing in the comment box. So next we have Arpita. I'll add her to the stream. Hey Arpita. Yeah. Hi Arpita. Can you hear me?
Yes, I can. Can you hear me?
Yes. How are you doing, Arpita?
Great. It's
Awesome.
Friday today and weekend on the way, so obviously it's great.
Yeah. So thank you, Arpita, for joining us today at jCloud Day.
Thank you so much for having me here.
Yeah. See. So before you, we had Haimantika, and now we have you. So you are the last speaker for today's conference. So before going forward, Arpita, I would request you to give a quick introduction about yourself, what you're doing, and what your session is going to be today.
Okay, so hello everyone. I am Arpita. I am a Microsoft Learn Student Ambassador, and I am also a LIFT scholar, Linux Foundation Scholarship scholar, and I am also a web developer and a cloud enthusiast. So this is all about me, and later on I'll share my socials with you all. I'd love to connect with you all. So can I share my screen now?
Yes, Arpita.
Okay. I'm sharing my entire screen because I'll be needing to move around tabs. So
Sure. No
can
problem.
You see it?
Shall I put it on the screen?
Yeah, sure.
Okay. Here it is, Arpita.
Great. I hope that you are able to see the presentation.
Yes, Arpita. You're good to go.
Great. So today we will be discussing about how you can deploy a website to Azure. So it's an interesting topic. It's a very interesting topic. And let's see what we will be covering today. So I have already given my introduction. So these are my social handles. You can definitely ping me anytime. And we will be covering today what is web hosting, what is Azure App Service, what are resources in Azure, and we'll be trying to make a sample app and we'll host it on Azure. Then I'll be sharing few resources with you that might be helpful to you further. So let's move to web hosting. What is web hosting? So let's first talk about localhost. What is localhost? What you do is you code HTML, you code Java, or you just for JSP, you just code and you set up a local server on your system, and then you try to access that file using your browser. What your browser does, it renders the information and boom, it displays the website. But there's a catch. There's a kind of catch. What it is, you can only access that file using that particular system in which the file is stored or on the connected system. Like I can access the file which is on my laptop to my, I can access the file using my mobile phone. But I cannot access that file using my sister's mobile phone because currently it is not connected. So the idea around localhost is that your browser can render that information which is already on your system. So how about putting that same file on server? For instance, you can like think about like what server is. So it is a computer. It's just a computer that provides services to several other computers. That's a server. So by doing this, what will happen is by doing this, your file will be on server. So every connected device on the internet, every connected device to the internet will be able to access that file. So that was all about web hosting. So I hope that you are clear with it. There was one more thing which I'd like to discuss is what is client and server. So client and server, this is the model which we use in today's era. So your own browser is client, and the server is basically that computer which will provide the services to you. So what client does is, suppose you need to go to facebook.com. What you do is you open up your browser, like type in facebook.com, and then boom, you just put just press the enter key, and your client makes a request to server. It goes to server and say, hey, do you have something associated with facebook.com? Then server searches in its storage and says, yeah, I have something associated with facebook.com. I am sharing it with you. So the server sends the data and information to the client, and the client displays the data to you. That's how the system works. So that was all about web hosting. The next is what is Azure App Service? So Azure is a cloud service by Microsoft, which helps you to deploy, manage, build apps on cloud. So these services are generally like managed by Microsoft managed data centers. So before moving to like what is Azure App Service, I think it will be helpful to know how it came into existence. So back in 2012, or I think even maybe before than that, there existed a service mainly known as Azure Websites. So what was it? It was specifically for the people who wanted to publish their web on Azure or to Azure. So after seeing a lot of demand, what Microsoft did is they added few broad services like mobile apps, API apps, web apps, functional apps to this service. So later on, all you can see is these are like broad services. What Microsoft did is they containerized, or you can say they put all these apps or all these services into the same big family, and they named that family as Azure App Service. So I hope that's clear with you. So how it came. So what exactly it is. Azure App Service is a service by Azure which will allow you to like access these services like mobile apps, API apps, web apps, functional apps at the same time. So every time you will see is Azure App Service will provide you something different to the table. So that was all about, yeah, one more thing I want to discuss about Azure App Service is you never need to worry about underlying servers, storage, networks, or anything. It is just managed by Azure. What you need to do is you just need to focus on your application, what you want to show to the people. You never will be needing to like worry about servers. It is completely managed by Azure. So that's the main benefit that we get by Azure. So the next is, what is resource in Azure? So I'd say resource is any freaking thing that you create on Azure. You'll say that, Arpita, are you crazy? Is it? So, but yeah, actually it is. So resource is anything that you create on Azure. Technically, like any entity on Azure is resource. So there you can see this hierarchy on the system, that every resource belongs to a resource group. Resource groups you can think like as folders where you can organize your files. And every resource group belongs to subscriptions, and every subscription belongs to a management group. So this is what the hierarchy is, and this is I'd like to show it to you. So I think it's time to move to Azure portal and see how the things actually work. What we will be doing is we will be creating a sample app, and we will be creating a sample app. Then we will be deploying that sample app and we will see what we get. So let's create a resource. Here you can just move to, if you are like having the subscription, you can just follow along with me, or you can just note down the points and follow later. So you need to go to portal.azure.com, then click on create a resource. Okay, so today we are creating a web app, Java web app. So just go under the web market, just create a web app, and it will take some time. Oh, sometimes you will get these kinds of errors. You just don't need to worry about it. Azure sometimes just behavior. So you just need to refresh, or if you have some severe problems, you can definitely try the troubleshooting thing. I hope this will work now. Okay. Actually, when you are using like IDs, they need to be refreshed. So I think that's the problem here. Okay, till the time it is being done, I'd like to tell you how you can get a free subscription. So if you are a student, so you can use your student ID to get the subscription, Azure subscription, and you will be getting, I guess, $100 credits on Azure. That's awesome. That's awesome because it's enough for a student. $100 are enough for the students. So yeah, we got it. So what we did till now is we created a web app using the web market family. So what I already told you is every resource belongs to a resource group, and every resource group belongs to a subscription. So today I am using concert subscription because that is what my subscription allows to me. You can use any other thing. Next is just choose a resource group which is suitable for you. According to my subscription, this one is perfect for me. So yeah, name is something which you need to keep unique. Okay, so let's just keep something like Arpita Srinivasa. Yeah, my own name. So next is publish. You can either publish a code, or you can publish a Docker container. Just choose whatever is suitable for you. We will be publishing code today, so we have choose code. Next is runtime stack. What it is? It may seem crazy to you, but it's important. So runtime stack is the platform upon which your application will run. So we are going to use Tomcat 9.0. So you can choose according to what your web app will do. So Tomcat, for those who don't know Tomcat, it's an application, server application, which is built basically for Java, JSPs, servlets, and for PHP. Next is operating system. Yeah. So operating system here means that the OS that will run on your virtual server. We are creating a server, right? So this is the OS that will be that we will be running on our virtual server. Next is region. So this region from where your website will get hosted. So mine will get hosted by from Central US. You can just choose like any other region if you want, and if your subscription allows. And next is Linux. Okay, the next thing is app service plan. So app service plan is basically the monetary stuff. If you are doing something which is on the production level, then you definitely need to choose something which suits your needs. So this is a production thing, 3.5 GB memory and ACUs and all. But today we are doing a testing stuff. So we will be choosing F1 service that is free. So we engineers always use free stuff. So yeah. So next is we will be reviewing and creating it. Just click on it. Here you all can see that it is getting reviewed, but after getting reviewed, yeah, it's here. Then the next thing you need to do is you just need to click on this create and it will get deployed. So this procedure takes up to 6 minutes to get done, but today I won't be doing this because we have time constraint. So I have already done some homework and here it is. So after like creating your web app, you will get to see this window after going to your resource. So whatever URL you chose there, whatever unique name you put there, you will get to see it here. So just copy it. Let's see it what this particular thing renders. So it's jcloud deploy.azure websites.net. So here it is. You can see that it's jcloud deployed. So congratulations to all. We have done we have completed the first milestone. We have like deployed our resource. So it says that your app service is up and running. Our app service is up and running, and we just need to deploy. We just need to code and deploy. Okay. So let's move to Azure portal. Okay. So for your for deploying and creating the web project, you just need to go to Cloud Shell. Just hit this button and it will pop up the Cloud Shell. Okay. Yeah, here it is. So today I'll be using Sandbox, something different. Sandbox is mainly for the learning purposes. So I'll be using Sandbox today. So we need to follow along with some commands. And these commands will let you make your new project and deploy it. So what first we will be doing is we will be using Maven. What Maven is basically a project build management tool for Java. So today we will be using Maven. You can definitely use it. It's perfect. So let's create a new web project, and I hope you all are ready for it. So we will be using Maven. So for Maven, we write this thing mvn space archive. You just don't need to worry about these commands. I'll be definitely describing all of them. Archetype generate. What is archetype? Archetype is nothing but a feature of Maven. Okay. So the next is D group ID. Okay. It's example.demo. Then next is the artifact ID. Make sure that you capitalize a D every time and I every time. The artifact ID, which is equals to hello world. So what we are doing actually is we are creating a template for us. We are using a template by Maven, which will let us to like make a hello world application. Next is the interactive mode, and M should be capital. Is equals to, which is false because it's not production. So next is the archetype artifact ID, which is Maven archetype web app. So here it is. So Maven archetype web app, what it is basically a template. It's a template which will let you to use this stuff, which is known as like template, hello world template. So it's getting done. It will take some time to get done. So by the time I'll show you what are the next commands. So you just what you need. We have made our project. Next, what we'll be doing is we will package this application what we created for deployment. It's important that you package your application before deployment. So MVN package. This I hope you are able to see this. Let me just zoom up a little. Yeah. So MVN package. This is basically command for like packaging your application for deployment. So what this command will do? This command will produce a .var file. What is .var file? .var is .var file is basically used for deployment stuff. So, and after getting this stuff done, what you need to do is you need to run this command. What this command will, okay, so if you are using this deployment stuff for the first time, you just need to run this command, because we need to configure some username and password before doing anything. So this is what it will do. If you have already done this, you just don't need to do this all the time. And next is you just need to go and check the target folder. And within the target folder, you will get to see that .var file. You can just do type ls and you'll get to see it. Next command is, this is the command which will let you to deploy your application. So this is it. So var deploy. What is var deploy? Var deploy is basically service by web app service, which lets you to deploy var applications. So this is it, what we needed to do. Actually, these stuff takes time, so that's why I already did them, and I wanted to show what's the final product that we get. So here it is. Actually, I created a website. Let me show it to you. jCloud Day. Yeah, it's jCloud Day. I created jCloud Day instead of jCloud Deploy. Okay. jCloud Day Azure website.net. I'll just go to this thing and reload. If something like this happens, you just don't need to worry about it. It generally happens. So just chill and try refreshing and try troubleshooting the stuff. Okay, there's something weird over here as well. jcloudday.azurewebsites.net. So there's something weird with it. You'll get to see this hello world thing over there, but it's not working. I don't know why. Says that it can't be reached. Maybe some issues with internet. But later on, can you all please check it on your mobile phones and every device? It's deployed and you will get to see it. So if it's possible, just check around, and that's it from my side. And I'm sharing this resource link with you all. So it's http bit.ly/Azure resources. So here you all can see the resources that I used and that might be helpful for you. This is the slide deck which I used today, and this is the learning path which I used today, and these are the commands which I used for deployment and creating the web app. So I hope that was great and enough for today. So that's it from my side. Thank you so much, jCloud, for providing me this opportunity for coming and speaking at an event.
Thanks a lot, Arpita, for sharing your insights.
Thank you.
Java and Azure. I hope you really enjoyed presenting here.
Yeah, I enjoyed it, and the site doesn't work at the last moment.
No problem. There are sometimes a few things doesn't go with us. So anyway,
Yeah.
it was really nice to have you, Arpita, with us. So
Thank you so much for
share
having. Sorry.
yeah, so we'll be sharing the slide deck of yours with our participants so that they can go through it.
Okay.
And we hope to have you in our future events as well.
Thank you so much. That would be a pleasure.
Awesome. So thank you, Arpita, for joining us today.
Thanks so much. Bye.
Thanks. Bye. So guys, that was Arpita. So with this, we have come to the end and we have finished all the sessions for today. As mentioned, starting from Srinivasa's session, then we had Sandra from Microsoft, then we had Rory, and after lunch we had Arvind, Putrevu, then we had Soumyadip, Haimantika, and at last we had Arpita. So as mentioned in the starting, we are going to announce the winners for quiz, for which most of you are waiting. So before going to that, I'll share the learning resources and the Azure Dev Challenge again with you guys so that you can go through the Azure Dev Challenge and participate in that and earn your Azure Hero badge. So I hope you guys can go through it. So guys, here is the Azure Challenge. So the link we'll be sharing in our comment box. It's conf.me/jcloud-challenge. So we'll be sharing the link in the comment box. So what you need to do in Azure Dev Challenge is you just need to go through the learning paths, which is mentioned here. Out of these, you just need to complete one of the learning paths. After completing any of the learning paths, you just need to share it on Twitter with your MS Learn profile and using the hashtag jCloudDay. After you do that, you just need to subscribe to the Microsoft.source newsletter, which is already there in third option. So guys, you can go through the learning paths, which is mentioned here. So we have really cool learning paths for you. So you can complete any of these to earn your Azure Hero badge. Also, we have the Microsoft.source newsletter. So guys, this is a monthly digest of all the relevant technical contents and the events happening nearby you. So you guys can go and subscribe to it. Also guys, regarding the Azure Dev Challenge, we would request you to make your Twitter DMs open so that we can reach out to you and share the Azure Hero badge with you. If your DMs are not open, then we won't be able to ping you or share the Hero badge with you. So also regarding the speaker slides and all the learning resources, so we have made a GitHub page, so where you can find all the learning resources starting from the morning sessions. So here you can go and find the speakers profile for all the speakers. Then we have the speaker slides. So here you can find the Azure Dev Challenge link. Then we have the learning resources for you. And at last we have the Microsoft.source newsletter. So we'll be sharing this link as well in the group and also to the participants who have registered for the conference jCloud Day. So if you could see, this is the official website of jCloud Day. So we'll be updating all the learning resources and the speaker slides in this website itself. So we'll be sharing out the link and everything in the post event mailer. Also for those guys who are waiting for the feedback form. So guys, we'll be sharing the feedback form in the comment section now. And I would introduce Ganesh from KonfHub to announce the winners for our quiz. Hi, Ganesh.
Hi, Rohit. Are you able to hear me?
Yes, Ganesh. How are you doing?
Yes, doing awesome. So glad that the conference has come to a good end, and now we'll end with a very nice note. Completing the quiz winners as well.
Yes.
So you
Yes.
can share my screen.
Yes. Please share a screen so that I can put it on the screen.
Yes, done.
Yeah. Is there
Okay,
then?
all right. Yeah. So first, let's quickly see the. Oops. Let me close this. Make this full screen. Yeah. So here this is the answers for the quiz questions. Let's quickly review the questions and the answers. A newly released mobile app using cloud data storage has just been mentioned by a celebrity on social media seeing a huge spike in user volume. To meet the unexpected new user demand, what feature of pay-as-you-go storage will be more beneficial? So the answer is to ability to provision and deploy new infrastructure quickly. So this is the reason, and the reference is here. So what is the characteristic of non-relational databases? So the answer is it's either schema free or have relaxed schemas. So suppose you work at a startup with limited funding. So why would we go for cloud solution, right? So because it helps us go with a pay as you go billing model with no large upfront capital expenditure, capex or opex. These are easy questions, and the more tougher questions are later, right? So why we should when we should scale out our deployment when we need additional compute instances to speed up the application, like more VMs. Okay, you have created a bug fix on a new branch and wanted to become part of next prod build generated from the master branch. Sorry, what you should do next? So the correct answer is to create a pull request to merge your new branch to the master branch. Okay, so what kind of source changes will the typical Java project require in order to run on Azure? So no changes are required because Java is supported as a first-class app platform in Azure. So how does hosting Java apps and differ from hosting Java apps on Azure differ from hosting apps built for other platforms like .NET on Azure? So each app platform has its own dependencies, so developers need to ensure that the Azure target they're using is configured correctly. So what databases can Java app deployed on Azure connect to? Can connect to any database. Which troubleshooting command can be used to view container startup events within Azure container instances? So the answer is container attach, and it is not logs because container logs only shows the logs and not the startup events. An e-commerce application has a requirement to support a shopping basket. We can add and remove products and so on. And still seems want the flexibility to offer discounts, add or remove different product categories. So which API available in or which API will we choose from Azure Cosmos DB that supports these requirements? The answer is core SQL, right? Now let us see how many people have correctly answered the questions. So we have 60 submissions, and let's look at who are all the ones who answered all the questions correctly. So we have Hitesh, Tanishk, and so on. So we have 29 people answering correctly, right? Now, this being a Java Cloud conference, so we have a tiny little program written with all the names, and let the Java decide, or more properly, let the random function in Java decide who is the winner, right? So when I run this program, the name will be selected here and it will be shown on the screen. So let's run the program. First winner is Mamata GS. Second one is Hardik. And oh, Mamata is repeating. So let's give another chance. Kirti. The third winner is Kirti. So I will just select the winner names and share it so that we can contact the winners and give the prize of 500 rupees each. Yes, I think that's it with the quiz winners. So Thank you for participating in this quiz. Back to you. Over to you.
Awesome. Thank you, Ganesh, for announcing the winners for quiz. So also, guys who are waiting for the referral contest winners, so we would request you to DM us on Twitter. So we are sharing the Twitter profile of KonfHub so that you can DM us and we will get back to you with the details. Last but not the least, here is the feedback form, which we have already shared in the comment box so that you can go through it and submit your valuable feedback form. Also, those who are asking for the participation certificate, you can mention it there in the feedback form. So, guys, if you love this session and enjoyed it, please make a tweet on Twitter using hashtag jCloudDay. And this is our KonfHub handle. Add it, and we would love to hear from you. How did you like this session? Also, we are really thankful to Microsoft Azure for sponsoring this event and also with the learning resources and the materials. Also, guys, we had awesome community partners who helped us reach to larger audiences and make the whole event successful. So we are really thankful to Bangalore Jug user group, to Coderplex community, to Delhi and NCR Jug, then Elastic user group, then Girl Script Foundation, Java Meetup Bangalore, Jug Hyderabad, Kerala Jug, Mumbai Jug, Script Foundation, and women in machine learning and data science Mysore. So we are really thankful to all our community partners for helping us reach to more developers and audiences. So with this, we'll be ending today's session for jCloud Day. Also, guys, we have a few more events coming up. So we have our next conference called AI Dev Day. So we'll share the link in the comment box so that you can register for the event and join. So we'll be sharing the link in the comment box. AI Dev Day is themed around AI, ML, and cloud-related technologies. So it's happening next month on 25th. So we'll be sharing the link in the comment box. Please do join us for the event. So with this, we'll end up the session for today. So thank you all. Thank you for joining us today.